Thank you all for coming in and doing a great job moving everything out, setting everything up, and being patient while we get started here. We're going to proceed with the demos. We're going to skip over any closing remarks from everybody until the end while the judges are out deliberating, and then we'll do all the thank yous and we'll chat and all that. But we're going to dive right into demos. The way this is going to work is I'm going to announce the next 5 teams in order. First one up comes up present. The next team on deck, just be prepared. You don't have to like get up and stand next or anything. Just know you're up next, just so we can keep this thing rolling. And then after those 5 teams go, I'll announce the next 5 just so we can keep coming up and everything. If you sent me a presentation, I'll load it up on here. We'll find the tab and we're good to go. Otherwise, if you're hosting it off your laptop, come in and we should have adapters up here for everybody. HDMI is preferred. Everybody has 4 minutes, and then we get 1 minute of Q&A from the judges. They'll ask a few questions, and then we'll move on to the next team. In the interest of time, since there's 27 teams, I believe, 28 teams, there's a bunch, you know, I'm rounding up to 30. There are 27-ish teams, 4 minutes to present, 1 minute Q&A. This thing is going to go for about 2.5 hours. So when you have 1 minute left out of your 4 minute, Anita here up front, and well, I was going to say Space Apps t-shirt, but everyone's wearing one. Anita here will be holding up a 1 minute sign. When you get to 30 seconds left, she'll hold up a 30-second sign. So you can look out in the crowd, but focus on Anita also. It's very important. She will stand up and start waving in your face if she doesn't get your attention. When time is up, I will start clapping. You will start clapping. We will clap these team off the stage because we cannot, you know. There you go, just like that. Perfect. See, no one can talk over that, so it's a perfect way to keep this thing moving. So presentations will end, do Q&A, and we'll move on. So the first 5 teams up are SOS, FireCloud, Viewpoint, Aaron, me, and Demeter. So SOS, you guys are up first. I believe you guys have your own laptop. If not, presentation's on here. And then FireCloud is up next. So get ready. When they're done, you guys are going to come up and present. Okay. You guys have your own laptop? Okay, cool. There's HDMI, you can take the adapter. If you guys got space, you can like, you know, throw them back here. Otherwise, you know, whatever works. Yeah, we're gonna start.
We're going to sing. I don't know. You had your headphones and we decided we were going to sing a song. So
Okay. Hey guys. Oh, yeah, the back one. There you go.
Okay. 30 seconds.
Oh no. You're going to clap fast.
Mirrored? Not mirrored?
Is it? No.
Mirrored.
Is it? We're going to have to drag it over.
Other way, I think.
No. Wait, why don't you do it?
This is why we encourage you to
There you go.
our laptops and get this thing moving. FYI, it might be mirrored, so just drag it around until you find the edge and it gets on the other screen.
I think that's good.
I've had trouble with this.
Do you want to present it like that?
Right there.
Yeah. Okay. All right, everyone. Hello, we're SOS, Sink or Swim. And this is our presentation. This.
This has been our experience of the entire
Yeah.
hackathon so far, is waiting for the Wi-Fi.
Yeah.
Let's skip this.
We could.
I forgot to announce, if everybody can kill Wi-Fi if you're not up here, it would do a big help for us as we're trying to load YouTube videos and everything.
Okay, yeah.
Let's just skip
No,
the
that was
video.
going to be a meme, but forget that. All right, so, okay, so Hey everyone, we're Sink or Swim. We made a game about planning for the unexpected and learning about disaster preparedness for you and your loved ones. And of course the challenge was don't forget the can opener. And so for our app, for our web app, what we decided to do is limit it to 4 apps, 4 situations rather: tornado, wildfire, hurricane, and blizzard. We had a few other situations and hazards in mind, but when we were creating this, we decided to limit our scope to what are the most frequent situations here in the United States. And then we kind of like revolved around that concept. So this is our original like planning stages. This is what we originally thought of when we were building the app. And our concept was basically this idea that we randomly generate a human being, and then they go through this game where basically you have to go through every single circumstance, like every single hazard that you're incoming, and you have randomly generated age, location, and like familial status. Like you can have like 4 children and a pet, and you're like a single parent. You have to grab them all and you have to get out. And versus like a person that could just be you, and what do you have to do to leave? And this was like our original decision flow. This is kind of like the design what we were going with. So originally, when we were going through this, we decided to create a story, and that's like a randomly generated story, so it could be different every playthrough. And then, yeah, and then as you go through, we give you the disaster that you are incoming. So it's something like you have a location as is, and then based on that location, these are the most frequent hazards in your location. And as a result, what you have to do to react. Are you going to stay, or are you going to leave? And then even on top of that, we benefit the user or like punish the user for whether they stay or whether they leave, depending on the hazard. And this is like the example that we were talking about. These are like the main case that we're looking at, like the age, and like health status, and whether or not you had a pet. So we were just like, okay, you randomly generated. Some people got really great luck, where they were just in a place where they didn't have frequent hazards, or they were just like, they were single, and they didn't need to worry about anyone else. They didn't have any medications, versus someone who has to care for a lot of people and a lot of animals. Yeah, and 4 pets. So imagine that. Cat ladies, you know? So yeah, and this was like the disaster screen that we were referring to before. So this is the stay and evacuate. And sometimes depending on the situation that you're in, staying is a better option. So like when we were discussing these cases and we were going through the data, we were like, okay, if it's something like a snowstorm, obviously you're not gonna wanna clog up the roads. But if it's like a wildfire, you're gonna have to run out there. And this is the stage that we spent the most time on, because it was like we had to add point values depending on the situation to several different evacuation items that you need. They could be like, and we created like a variety of items, which like, it could be very simple, like a flashlight, or canned food, or cash, or as you can see in the backpack, a gun, right? So yeah, some people, they need that. And this is the take action screen. So you have several different actions that you had to choose from, and based on those actions, we punish the user or benefit the user. And it was just like a very binary, like +1, -1, because all of the data was already kind of like preset for you in the random generation. And did you sink or did you swim? And you can see if you chose all the wrong actions, you picked all the wrong things, of course you sank. And if you picked all the good things, then you swam. Yes.
Hi, so who is the intended audience for this?
So we were trying to go for like a more variety of audience. Like we didn't think of a specific audience. We were just thinking of people who are in coastal regions for the most part in the US. Because for most of the disasters that we found, it was either predominantly in the East Coast or predominantly in the West Coast. Like we don't have wildfires or earthquakes frequently here in the East Coast. But there in the West Coast, they don't frequently have hurricanes or blizzards. So it was kind of like those 4 cases we were just like focusing mainly on the coastal regions. I don't know if that answered your question.
Other questions?
I have one question. If you had, let's say, one more week to work on this, what would you add to this project?
So we actually had a lot of different ideas. First thing we wanted to add is like maybe diversify our location. Since we were like, we had to narrow down our disasters.
Yeah, okay. When we're answering a question from a judge, we can let them finish the answer and then move on to the next one. I love the enthusiasm. This is how we're going to get out on time.
Wait, why can't you plug it on here? No, I'm gonna be here. So just squeeze that over. Hello? Oh. Hello. Okay. Yeah, move, keep.
Ready? I'm just gonna have to hold this.
Yeah. Can you let me know when you start the timer?
Timer started.
Okay. Hey, we cope with it, we stay warm with it, it's a part of our everyday lives. They can also harm us, destroy us, and everything around it. The biggest double-edged sword on Earth, fire. On average, according to the NFPA, there's a fire every 24 seconds within the US. With the current advanced rise of technology, it's a wonder why preemptive and first response technology don't exist for such. So we developed FireCloud. My name is Tay, I'm the blogger of Chapter 1.
I'm Ruben Gosens. I'm a software engineer at Rescue South.
FireCloud is an all-in-one series of preemptive protocols and first response in order to avoid and minimize the destruction. Leveraging current trend technologies and new media outlet tactics, we were able to build a solution that could help save lives and properties. We are tackling the Spot That Fire challenge. So let's play the demo. We developed an iOS app that targets two types of users, the victims and the helpers. So when you first launch the app, you're able to choose from one of the following. So let's choose a victim view. There's 5 things you can do. You can call for help, you can go find shelters and food, and you can find the nearest shelters, and these are all randomized because right now we haven't populated the shelters yet, but you can click on any one of them. So let's say we go to We Belong Together shelter. We can go on the directions and be able to go towards that shelter immediately. Now, let's say that you notice that one of your friends is missing. Let's report your missing friend. Let's go, Jerome is missing, even though he's clearly here. So let's go, Jerome. I actually don't know his number, I'm sorry, but you're a good friend still. And he's tall
Broken heart right
and
there.
has black hair, okay? Report missing,
Note right here, the blue dot appears in real time.
right? And let's say there's a fire. So, oh my God, there's a fire right there by the judges. And we're able to select the location, your current location, so you don't have to select it. You can select the image, so I remember online it said to choose an image, and you can select the intensity of the fire. You can report it. Oh, there's a fire here, guys. And we haven't implemented this yet, but we have a solution for an offline version as well, where if you don't have internet for whatever means, you can see the list of protocols and stuff to take. Now, let's go to the helpers view. So over here, this is if you're a helper, if you're a firefighter, volunteer, or first responders, you're able to see the fire. You're able to see if you're being helped. You're able to see how many people are affected, list of number of firefighters deployed, volunteers deployed, number of missing people, and you're able to see all of this in the web view as well. And leveraging social media to notify communities at risk to allow people to subscribe fire warnings, current fire and smoke levels, because there's no other way to spread information nowadays other than Instagram, Facebook, Twitter, and such. And you're also able to verify if your fire has been extinguished or not. And now we'll move on to the web demo.
So the web demo is done entirely with real-time technology. We're using Firebase, a Google Cloud product. We're able to, to get data from all kinds of sensors. We didn't implement all of them, but we stuck around with just the very basics, location, time, name, and this and that, just trying to put it all together. This idea is to try and build it for firefighters to say like, hey, we're on the front lines. How do we track to see how progress is moving along, as well as when someone's in trouble, right? Say, for example, they have a heart attack. We'd like to know before they pass out. We'd like to be able to use data analytics on this to not only capture data real time and analyze it as we go, but also to use it for educational purposes later on.
And we understand that even though fires do occur frequently, we never expect it to happen to us, so we want to be able to make this app more appealing to those who are not afraid of fire. We want to make this part of everyday students' lives, potentially make it mandatory as their monthly fire drills to go over fire safety protocols and solutions using this app. So, that's our app, and thank you very much, and now we're ready for questions. Oh, by the way, we're looking to deploy this app online, whether we win or not, because we actually got pretty far in the development process. So, look towards FireCloud. Yeah.
Okay, besides the user-generated data, is it using other data sources for historical or?
The data that's currently a manual input is actually from our phones. We needed to be able to use a little more widespread data, and that's what we loaded. Obviously, Donald Duck isn't sitting in Central Park, we have actual GPS data coming in from the phone, and we're able to upload that real time on the fly.
Yeah, this was more for like user-facing, for helpers and victims for first respond, but we'd like to, for the web view, we'd like to use open space data and like any other data out there to help find potential fires and like where it could like most likely show up and such.
And additionally, this fire-based technology, it's meant to scale. So, this is just a little glimpse of the potential, right? The Firebase is used in Google Cloud, and it's huge.
Thanks, y'all.
Thanks. You want
Next up is Viewpoint, and then after that is Aaron Me. You guys on your laptop? Yeah. Okay.
It's USB-C. Oh, yeah. Oh, it is? No, I use this one. Yeah. Oh, see, I forgot.
Just remember. So after I was saying our areas, that's
Okay. Good afternoon, everyone. We're Team Viewpoint. My name is Enrique, and these are my team members. This is Jeff, Gotham, Faiz, and Presley. Our concept focuses on using satellite imagery to exhibit past and present ecological events while identifying the Earth's most important components of its geographic coordinate system. Given the ability to get past the limitations we went through, our extension would be used to focus where pollution is occurring around the world and also detect fresh water in arid areas. And this would be sort of like an idea of how our mock-up would look like. So we would use satellites, but in this case, we have like a duck replace the satellite here. But Jeff can tell you a little bit more about it.
Yeah. So unfortunately, in developing this project, we hit several issues today where the API that we were hitting, the Satellite Situation Center web services, just stopped giving us back what we wanted. So we got a bunch of 503 errors. So unfortunately, currently the app looks like this. So we're using the Whirlwind virtual globe library to render this image. And our hope was to be able to fetch data on the locations of a set of satellites over a range of time, and then basically just take on the point of view of that satellite as it's orbiting the Earth, and have the sort of like contrivance of seeing what it sees. Obviously, satellites don't literally see like things in like temperature, color, spectra that would be meaningful to a human, but just sort of like having an overlay of that on the globe as it's traveling around was what we were hoping to do. Did you want to talk about?
yeah, sir. Oh my God.
Okay, well, so given that we had all those challenges and we have like not really much to show, I thought it might be valuable to talk about some of the things we could have done like better to have something to present for you. So given that the API can't really accept requests of a particular size, like we had started requesting for a ridiculous number of satellites, like 200 something, I think like going forward, it would have been great to make a whole backend first and actually pull all the location and satellite data, because there is something valuable here in that there's not a lot of good comparative satellite data that can provide information with the speed of a casual user wants when they're trying to like compare what different views satellites might have on things like pollution on different parts of the globe, right? So these APIs, they're trying to send you like everything at once. If we crawled them before and then just took the location and all of the most relevant data separately and serviced that from a backend, then there could be like a smooth user interaction. So things like this slider and the day picker would actually show you different satellite positions live. And when you clicked on them, you would see the satellite's perspective of the globe as a whole. So it's just sort of some things that we probably should have done better.
Thank you so much. So my first reaction when I heard you describe what this is about is, wow, this would be a really cool spy network, right? So I don't think that's your intended impact. So can you share with us, why is this important? What impact are you trying to achieve?
Sure. Well, I think the impact we're trying to achieve is, it's not that there aren't sources of satellite data for things like trying to determine upcoming ecological disasters or things like that. I think it's just harder to find comparative data between different sources, right? So you can look at the feed for a satellite somewhere, but it's really hard to take the feed of one satellite, take the feed of another, and compare very quickly so you can get a sense of what's actually going on. And I think there's a learning component to that also, because people who are just trying to enter into fields like that, they're encountering a high barrier trying to access this kind of data programmatically and just looking at numbers and like heat maps and trying to look at them side by side. So.
All right, that was fun. Everything the mic does, we can hear on the live stream, so please be close to the microphone and talk right into it. Almost eat the microphone. Don't be on it, but be near it, just so we could hear it on the live stream and we don't get you kind of like zooming in and out. Also, preferably if you can keep it on the stand, that'd be great, but we know there's a lot of people up here and there's not a lot of space, so let's do what we can. Next up is Aaron Me, right? And then after that is Demeter, followed by Casa, and Unicode Unicorns. Aaron Me? No? Okay. Next up is Demeter. We're skipping Aaron Me. If they show up in the end, we'll throw them in. Demeter, you guys are on here, right? There you are.
Do I need to?
Should automatically.
Okay.
Yeah.
How do we?
How do you go to the next?
Hey guys, my name is Minyoung Na. And I'm Hannah, and we're going to use satellite data to optimize food production in refugee camps. So there are currently around 2.6 million refugees living in refugee camps created by the UNHCR. And there are over 40 million internally displaced people who may be living in other settlements. These people suffer from malnutrition because of a lack of food, and especially a lack of fresh vegetables and fruits. To solve this problem, we're going to use data to tell refugee camps what the optimum crop to be growing is at any given time.
So using the data obtained from the satellites, we extract it, analyze it, and choose the optimal crop looking at the average temperature and average precipitation over the course of time. And as you can see, there's some relevant nutritional information like calories, and along with that also cost and this duration for its maturity. So I'm going to show you a quick demo with Hannah. Oh, wow. If you click a desirable part of a map, maybe near your campsite, can you zoom in? Okay. Console. Okay. Okay. So we chose a part of a map, and it identified the correct coordinates, longitude and latitude, and it withdrew the correct temperature, and it's calculating its average precipitation, and it goes through the candidates of plants currently there, and it shows spinach as the best vegetable, because spinach can grow in really cold environments. And if you click the results, it shows you, it goes to the page where it shows you the information that would be necessary.
So
I think we're back. Cool. It's a presentation, so.
yes. Okay. So when the user clicks our map, we obtain the latitude and longitude. And then we go back 1 year and look at the average temperature over a 60-day period taken from NASA's Power satellite imaging data. We also look at the average precipitation over the 60-day period. We also take into account region-specific information, such as what crops are locally available and affordable, and what foods are commonly eaten in this area, so that the foods are familiar to the people eating them. Our app presents the optimum crop to grow at any given time in a simple and easy-to-use fashion.
And although we initially began this project to help solve hunger in refugee camps, we learned along the way that by using this app, we can create a better society within the refugee camps because it gives them more sustainability and more authoritative rights. Thank you.
Thank you.
What data did you use to figure out spinach?
So we look at, okay, it's not here. So we look at the optimum temperature range for a given set of plants, which are pulled from the locally available crops. And then we have like the absolute minimum those crops need to grow and the absolute maximum. If the average temperature of that region falls within that range, then that crop is put into our list of possible vegetables. And then we look at the average temperature, and if it falls within the optimum minimum and the optimum maximum, then we select that vegetable as the best vegetable, along with info about precipitation.
What did you build the backend on?
JavaScript, HTML.
Yeah.
Thank you.
Thank you.
All right, up next, that was Demeter. Up next is, how do you pronounce this, Casa? I've been stumbling over all day. Casa, and then after Casa is Unicode Unicorns. Can you guys open the door right here? Casa.
Introduce yourself, or are you going to introduce yourselves?
Yeah, I think we should all introduce
I have a loud voice. There you go.
You guys should start. Okay. Are we supposed to start? Are we good? Good. Hi everyone, my name is Kulan Migvadarj. Hi, I'm Sneh.
I'm Alex Markinson.
Alfonso.
And we are Team Casa. So we actually wanted to give a little bit of context before we kind of show you what we built. Currently, there's about 40 million internally displaced people, or IDP people, worldwide. So what you can refer to as an IDP person is slightly different than what you refer to as a refugee. So a refugee is someone who is being displaced from their home and leaving the borders of their country. An internally displaced person is staying within the confines of their particular home or home country. We decided to actually focus in on a pretty focused data set here with Nigeria specifically, and the Nigerian data population is 1.7 million people who are considered to be IDPs. Now, the challenge that we went ahead and tackled here was the land where displaced people settled. So we felt that this was a really impactful kind of challenge to tackle because IDP populations are constantly growing year over year. However, it's always been quite a difficult thing to track in terms of population densities, where these settlements, both formal and informal, are being tracked and created, and also how do we also get the optimal care for this IDP.
So the medium that we targeted is it's an app, like a mobile app, whether it be on an iPad or an Android phone. This is an early version of the app that we built. In this page specifically, you get a list of the top 5 IDP scores depending on a rank, depending on an algorithm that we wrote internally. And then when you click on one, it would route you to the specific one. This is the second page of the app that we built. This is just a list of all the IDP camps in the specific country. For our use case, it would be Nigeria. And then also you see the rank that we give it depending on the algorithm that we calculated internally. We'll go more into details like what we take into account for that algorithm, but that would essentially be another screen. And then this is a quick demo of some of the things that you can do in the app. So just click it. How does this work? Where is it?
Click on here.
Just click on it. Just go here. There we go. Go to page. Oh.
Can't see it.
I see what you mean by that's hard.
Then, you want to replay it?
Sure.
Replay that real quick.
Probably not that.
I'm not sure what the continue is.
Click away.
I don't have a Mac.
So essentially, you can click on one and you can see the data associated with that camp.
It's only 20 seconds.
For Nigeria, just because Nigeria isn't really covered as much as US is and most of Europe. So here you can see we have a list of 12 data sources that we got, such as access to potable water, health support, vegetation index, availability of facilities. shelter support, population density, distance from user's location, income generating activities such as jobs, educational facilities, food support, protection support, and near major cities. So one interesting one that I want to mention is vegetation index, which we actually had to hit another API that would calculate essentially I think it was the NDVI, which is the vegetation index of a particular polygon on the Landsat 8 imagery data. So each of these data sets we offered to create a majority to. That's just the weight of the data.
Questions?
Here we go. So what's the target audience of this?
So the target audience would be IDP people themselves or officials who are trying to help IDP people themselves. That would be the target audience. So it would be more of like a mobile app, right? So it would be either on an iPad, or on like an Android device or something like that.
What did you guys use to build the demo?
So we didn't get to the last few slides, but we used React and React Native for our UI. We had Node.js, Python, Flask for the backend, so for the data analysis and the API calls. And then we used data sources such as these for some of the data that we used. Any other questions?
Thank you.
Thank you.
All right, so we're going to try something new. We're iterating here. We're going to have everybody hold the microphone in their hand so they could easily pass it between different heights and whatnot. Jolie here is putting down some tape, so we just request that you stand on the tape.
This is because on the live stream it's split screen, so you're cropped, because we've got that taking up most of the screen, so you have to stay in the one spot.
Yeah, so you shift and then you're gone. So we'd like you to try to stay in one spot. A handy trick is to just hold it, put a finger in your face, near your face. Oh, sorry, yeah. Can you just announce your team name?
Unable to connect. Awesome. All right. Are you ready? Okay. So we are the Unicode unicorns. We like to think our motto is grab life by the horn. We did the Polar Opposites Challenge, and the most important part of this challenge was analyzing and visualizing NASA's Arctic or Antarctic ice sheets and the sea ice data to tell their story over time.
We thought a lot about what kind of data set that we wanted to use. We knew that ice floats in water, and we could use something like elevation above sea level and the Archimedes principle to figure out what the thickness of ice could be. But as we were looking around trying to find this data set, we found one group called Operation Iceberg and the National Snow and Ice Data Center, which had a data set available for us that had the exact values of the thickness of the ice sheet in the Arctic region based off of latitude and longitude. This is the data set that we used, which happened to be in NetCDF format.
And what is this even? We didn't know either. And after a few hours of researching, we found out that NetCDF documentation and learned that there was an R package to handle the data. As you can see from the diagram, it takes in 3 types of information: user, Unidata, and third party.
We then wanted to represent this data. We couldn't just throw it onto something that was just an XY graph of the map because that wouldn't look quite right. Instead, we needed to convert these values into a polar grid and then plot each of the values for those longitudinal and latitudinal values with color coding involving the thickness of the ice sheet.
And then our final problem was generating the metrics. This is where we ran out of time. We have several data sets parsed and ready to go, thickness, mass, volume, water temp, etc., but they all need to be combined into one UI still. The Python data and the R data are still separate, but they still tell a unique story.
And so this is an example of what that data looks like. On the left-hand side, you have a line graph that shows the overall mass in black of the ice sheet, and then in red, the surface area of that ice sheet. And we can see this over time, looking at September, then December, January, March, and then finally May.
It's demo time.
So looking at our data, what we work with is just a simple script that calls in each of the data sets that the National Snow and Ice Data Center provide. Each of these are saved under different dates, and they load in the different values using a function that simply reads through that file, and then saves the latitude, longitude, the thickness, and the day for each of those values. You can see this going through each of those days on the bottom. It's hit March at this point of this single cycle that we're looking at, where the cycle begins in September and then finally ends in May. They don't take very many, they don't take any data points during those summer months. Once it's finished with that, it then will parse through each of those values for individual days, unique values, calculating the surface area and the overall mass of the ice sheet. I think this data set is really cool in the way that these values are relative to one another. We don't have to necessarily look at units quite yet or transform these data points. And if we look at the dimensions of this data set, we're looking at nearly 2.5 million observations. And so the less transformations that we need to do in order to be able to understand what we're looking at, the faster we can come up with results.
And the last thing we want to say before we run out of time is we also wrote an API script that queries the world weather online, and it brings us weather temperature, ocean temperature, and all other sorts of information that helps us to gain a knowledge of what the ice is doing.
Okay, thank you guys. Thank you.
Next up is Arctic Reality. After them is Safety Can, followed by Team and Kernel Panic. So right now it's Arctic Reality, followed up by Safety Can. Okay, you guys are not Arctic Reality.
Yeah, I'm Arctic Reality.
You're on your...
Stand in between the two.
Do you want to plug the issue line into that?
Yeah, sure. Sorry, just one second.
Yeah, no worries.
Sorry, I didn't realize that was going up next.
Cool. gonna put that over there?
Sure. Hi everyone, I'm James. I'm currently a computer science student, and this is my team's project, Arctic Reality, helping the public understand the reality of climate change through augmented reality. So some background, as you know, climate change has caused rapid melting of ice sheets in Antarctica. And this rate has tripled since the last decade. Every year, there's almost 200 billion tons of ice that are melting and falling into the ocean. While this is a fact that many of you may be aware of and have a general sense of rising sea levels and the concept of climate change, the actual sense of the data that you may have of this trend is represented in graphs such as these, or other more like difficult to understand scientific graphs, but there's no intuitive understanding of just how much our changing climate is impacting our ice structures on Earth. So our team's solution was to interactively visualize these ice structures in 3D over time to see how they change based on the current trend of warming. So we decided to represent this in augmented reality, since you would be able to see as if in the space in front of you just how much, given the current trends, ice will melt. So we built this first using data from the Antarctica digital elevation model, which is provided from the reference elevation model of Antarctica, REMA, which is the, data that the University of Minnesota compiled from NASA spacecraft like ICESat. From that, we used software called QSIG to convert this elevation data into a 3D model that we could then put into an augmented reality platform called Spark AR Studio. And this is an augmented reality platform that Facebook recently has developed for creating AR content on their apps and Messenger and Instagram, which we thought was a very accessible platform that could share our app. So in our app, first you tap and hold to place Antarctica, and after visualizing it, you can move it around and rotate it. Then by tapping, you step it forward 10 years in the future based on its current melting rate. And you can see over time just how much Antarctica will melt over the entire model. So here's a demo. So. Sorry. Oh, I have to press escape, yeah. Okay, so with your app in front of you, and now I'm going to tap and hold to place Antarctica. Okay. Sorry. Okay, I'm going to just restart it real quick. Okay, there we go. Sorry. So we placed it on the floor. So we have, it detects a horizontal surface like the floor and places it. You can see the height kind of if you go down and up. Then by tapping it forward, you move it 10 years in the future. And I'm going to tap it many, many times, so it's almost 100 years now. And you can see the height and ice slowly start to melt. You can move this around as well and scale it up and down based on your living room. So that's a demo. Thank you very much.
This was awesome. Thanks. So I have a question. You said that you can you predict in the future how it's going to look like. Does it based on the current temperature and size, do you take into account if something changes within those time interval?
So the data that is provided by RIMA is only was only a scale of like 4 years. So we just continued that rate and also kept the exponential rate of increase within those 4 years. So we assume that that there won't be any mitigating of climate change. It will just continue on its current trend. So.
Okay, cool. Thank you.
Thank you.
All right, up next is Safety Can, followed by Team, Kernel Panic, and Engine number 9. I also want to make a quick plug. James is a senior at Columbia University as part of the Columbia Space Initiative. They host a lot of really cool space events at Columbia University. So if you're nice to him, he may introduce you to astronaut Mike Massimino. All right, you guys, Safety Can, hold this. I don't think the laws of physics.
This is tight. Oh boy, I'm hiding behind you.
We have to plug in the phone. I get credit for this, right?
Oh, we gotta plug in one more pin too. We gotta plug in.
Yeah, plug something else in.
Whoa.
Yeah.
In between these two.
Whoever's speaking, just stand over here.
That's me.
Right here is like. We're not talking on Mac. It's an HD license. Oh, you want to do it? Yeah.
So I'm sending. Well, I'm standing here. Like, which one am I?
He's not standing on it.
Yeah.
No, I was saying, but they're scared of crossing it. You can cross it, you can't just stand on it.
Okay, I'm still confused.
So if you want to move out of frame, go off.
I'm just going to let you take it.
Dr. We, how's everyone doing?
Tell us a joke.
I ain't got none, so I gotta wait.
And there we go.
I'm actually in a gospel choir. Interesting fact. That's it now. Okay, we're Safety Can. There's a lot of us. This is our logo. As you can see, I made it. Graphic design is, in fact, my passion. Okay, so the challenge we took on is, I forgot the can opener. So, on our approach to the project, we really want to tackle the issue of the increase of extreme weather conditions due to climate change. And how climate change is affecting people who are elderly or have special needs or chronic medical conditions, and how that affects them particularly, and how our app really wants to tackle how information isn't readily available or easy to understand in the case of an emergency for these people. So the solution: what happens when you forget to plan ahead of time for an emergency? What happens when you forget your can opener? Safety Can is the solution. There are many other emergency preparation acts. FEMA in particular, FEMA, was kind of an inspiration, but we're not gonna pretend we did something like completely new or reinvented the wheel when it comes to emergency preparedness apps, but we think that our idea is something that is a step in a further direction to take it the right way by not just being a manual where you like read, you click links. It's actually meant to be more specific to the person and their needs. Like, say if someone has a bleeding disorder, they'll need to have clotting factor with them. The app will remind these people you need your clotting factor. If you're diabetic, remind you of insulin, and also tell family members how to administer this medicine and what to do in case of emergencies. This is an app that takes in that creates a family network along with emergency contact, and will make the plan accordingly. It will allow you to plan meeting locations in case the family is separated. It will give family members designated responsibilities. And also, aside from giving information, you can input information. So in the case of an emergency, you can have an inventory ready. So it'll tell you, you can put in like, oh, this is where I put this, and I need this, and the app will remind you of that. Because there are people who have memory problems, and they will be needed to be reminded of where those things are in case of an emergency. So here's a quick video I made to demonstrate our app. Nice music. Here we're demonstrating the AR. It's a map of the globe because we're going to use satellite. Here it'll tell you hospitals, shelter, any local organization that can offer you help in case of an emergency and how far they are away from you. Here is the app giving you steps depending on the situation you're in. See, there's like a hurricane, it wants you to stay inside. If the wind is over 80 miles per hour, you gotta board up your windows. Okay, thank you. Whoops. Here is the backend code written by John and Kenny, who did an amazing job. It reads, it takes your location and will see if there's any alerts for emergencies. And if there is an emergency, it will take data from the past certain amount of years and see what emergency is most likely to come up soon. Before, during, and after a crisis, SafetyCAN is with you every step of the way. It will remind you of the procedure and what to do. Contact information will keep the emergency contact updated in case anything happens, in case of medical emergencies. Manage inventory, I mentioned before. First aid, also instructions. In the midst of a crisis, app will give you the procedure again, location, first aid instructions, easy UI, user experience.
Questions from the judges? You want to see our AR?
Yeah. What's the point of the AR? The point of the AR is...
That's a more useful way of visualizing data information.
Yeah, so the way we thought about it was there's basically like two states with the app. One where you're in a state of a disaster and one where you're preparing for one. So we thought to make an informed decision, depending on where you are in the world, you can just click on the map and it'll give you certain information about nearby disasters, yeah. Or upcoming, sorry. Yeah. Do you want?
We have a slide that has this, because we didn't get a chance to actually implement it. We could just show that really quick. Okay.
So just a quick comment. There's like 8 guys here, not a single woman. Aren't you feeling like you're missing a woman's perspective when it comes to disaster?
We would definitely want more women working on the team. Definitely.
Thank you. I think all of this is yours, right?
To this.
All right, so SafetyCAN, your team. Yes, team. Team is up now. I'm just going to call you Team. Team is up now. Then it's Colonel Panic, engine number 9, and stage 1.
Is there a USB-C port?
Okay.
Is that USB-C?
Cool.
You guys are starting, right?
Cool.
So there's 2. Right there is good.
Oh, and then you step in a little bit. Yeah. Hi, we're Team, tracking extraterrestrial asteroids and meters. And today we're going to talk to you about what we sought out to solve. So we're going to go over the UX, the UI, the technologies, and the project goals. So much like the movie that we watched last night, beforehand we sought out to create a solution for what would happen if a meteor or asteroid was actually entering our atmosphere and being able to prepare people to evacuate the area. How would they do that if they don't know where it's going to hit? So we endeavor to prevent asteroids from destroying your joy, power, and possibility. Oh, you want to talk about that first?
Oh, I need to see. I need to show the front page. Yeah, so this is our front page. As you can see that we show the information of the closest asteroid. It's in Brooklyn. So yeah, if it's gonna hit the Earth, half of us will be gone. That's why we show this one. And you can also search for different ones. Okay, all of them are in our backend database.
Oh, I think you gotta move this over to the screen. Move the.
No, I don't have it. Okay, so
This is, oh, okay. So Michael, who isn't here, he kind of invented, or he made this sort of algorithm that takes in a bunch of data from the JPL API over here. And it takes in like mass, radius, some other stuff, I forget what exactly he uses, all this. And what this does is on post request to our post request, where's Insomnia? So let me just drag this over here. Oh, why isn't it showing up? How do I don't even know how to use Mac.
What do you want to do?
I just want to see Insomnia. So I can make,
This one?
no,
Which one do you want to open?
I don't. This right here.
You gotta drag it over.
I did drag it over, it's not showing up.
This? You gotta drag it over there.
There it is, okay. So if you make a post request to our database, obviously, we're gonna, oh, I'm sorry. I'm like shaking, I'm really nervous. I don't public speak a lot. So after you make a post request to our database, it saves it as an object. And now if we go to our API right here, let me just refresh the page. We have a lot of like the same examples, but it will add in the blast radius and that kind of stuff, and then they're able to get it on the front end. And we were also trying to use WebGL and 3GS to kind of like animate like a 3D image of a meteor hitting the Earth and kind of like use the blast radius like that. That's what, I don't know if you saw that square that kind of looks something like a
I don't know how it came out looking like a tesseract in that way, but that's supposed to be the meteorite shape, but it's getting there slowly.
Can you tell me a bit more about what data did you use?
So we used the JPL Sentry API, which tracks like near Earth objects that are like on. Oh, sorry.
And how up to date is this?
So they have like their last observed date in here and stuff like that, so you can kind of like filter data by that. But we haven't like really like on the back end side, I haven't set up a way to like just query this. I tried to, but my server wasn't fast enough to just like save 32,000 asteroids instantly. But so you kind of have to like do like data entry one by one. But until, yeah. So.
Was the Brooklyn example a joke, or is there really an asteroid that could potentially?
Yeah, that was not a joke. That was actually one that we were able to display. That was the radius of where it would drop. Yeah, so it's not.
That's not the actual trajectory. That's just like an example of like the size of the blast.
Are we also?
So, and yellow is where the impact would hit, and red is the area that would be affected.
So the goal of the okay. Thank you.
So you do not need to flee Brooklyn, unless you live by the L train. What happened? Yes, okay. So next up, those team. So Kernel Panic? Yes. Next after Kernel Panic is Engine 9, and then Stage 1. So here are two pieces of tape. I'd like you to stand right here, and then we'll get you in the entire shot. So you want to hold that. Let's see this. What do you need, HDMI? USB-C. I think that's this guy. I've never seen USB-C on a non-Mac before. I thought it was like a crazy Apple thing.
No, it's a crazy Dell
USB-C,
thing.
I thought it was just a Mac way to get money from you. Okay.
This thing moved.
Cool.
Oh, all right.
Stand in between the pieces of tape and pull.
There we go.
Okay, should we start?
Okay, cool. So we're gonna just take a minute break here, and if you guys just want to hang out for a second. Bathroom break. Cool. Okay. You guys gotta stay here though. Okay.
Hey, how are you?
Good. This is Team Kernel Panic. And just as a reminder, next up is engine number 9, and then stage 1, and then Lactase. All right, let's get going. There you go.
Time starting.
Hello, we are the creators of Disaster Master. My name is Ray. This is Ashley. This is Koi. This is Tal. And we are relatively new to web development, but we decided to tackle the can opener challenge. All right, so each year natural disasters cause approximately 68,000 deaths. That is an absolutely devastating number, and yet reports show that less than half of Americans are prepared for natural disasters. Exactly. So why aren't people prepared? Maybe they think that, natural disasters won't affect them. This is something that happened somewhere else. Maybe it's because, this is something that could happen in the future, but I don't have time to plan for it now. But being safe shouldn't be a challenge. So we thought, as programmers, how could we help? We wanted to do something that could impact others in a very user-friendly and straightforward way so that we could make things easier for people. So we created Disaster Master. Disaster Master is a very person-centered, straightforward checklist where you log in, you answer questions about yourself, like your family history, the youngest and oldest people in your family, any medical issues that you might have, including allergies, for example, or medications you need to have. And then it gives you the opportunity to look at different natural disasters, see what you need to do to prepare, and it generates a checklist for you that you can edit and customize yourself. So we built the front end using HTML, CSS, Bootstrap, and JavaScript. We built the back end using Flask, and we prototyped a bit with the Google Firebase API as well as SQL. And we did our graphics using Adobe Photoshop and the NASA image library. Okay, so here is a quick video. Okay, so you see that you sign in, and you can answer questions about yourself, including medical history. You then get to look at information about what to do during, before, and after these natural disasters. You generate a checklist that shows what you need in general emergencies as well as this specific one. You can add items that you want to take or that you feel you would need. They are added to the list. Then you can go down the list. You can check things off, get rid of anything you feel you don't need, continue to add things that you do. And once you're done, if you need to access it offline, you can save it as a PDF or you can print it out to take it with you. So why do we need Disaster Master? We wanted to increase this, the awareness that people have of the potential risks and consequences of natural disasters, because there is this whole, these things happen, they're bad, but will it happen to me? Do I have to plan for this now? And planning is different for everyone. A lot of people know, during a hurricane, you want to have purified water, but there are a lot of intricacies that go with it. One of our close friends has hemophilia and a severe nut allergy, and planning for emergencies for him would be a lot different than it is for us. In the future, if we could expand on this and work on it more, we would want to configure the code so that we could prioritize various items over others based on what people enter into the program, as well as we want to include more specific diseases and obstacles that people have so they can prepare for them better. Thank you.
Are you envisioning a mobile app version for this as well?
Yes.
And you had like a bunch of recommendations for each disaster. So where did you get those from? Those
So
the things that were flipping on the.
Yeah, so what we did, we researched a lot of different We looked at different places, what's recommended to do before, during, and after. For example, wildfires, hurricanes, how to remain safe, what to take with you. And we compiled it all into one place so that it's a lot more user-friendly and people don't feel overwhelmed by all the research they may have to do. Cool, thank you. No, not yet.
The demo you showed in the video, that was actually
Oh,
something...
that was real, yes. Yeah.
Oh, okay.
Yeah. Okay, thank you.
Thank you, Colonel Panic. Next up is Engine 9, followed by Stage 1 and Lactase. This is USB-C, but you can just plug an HDMI out there. Oh, we do. Windows? Windows, is it? Whenever, just stand in like this general area right here. Yeah, okay, perfect. There we go. Right.
Hi everyone. I'm Hector. I'm engine number 9. I worked like kind of remote for this hackathon. So what I ended up doing was doing the Spot the Fire challenge, and basically the problem that I was trying to tackle was that there are now a number of wildfires. There are more wildfires growing every year. The intensity is much higher every year, and it's affecting greater populations of people. In this international Space Apps channel, there was actually a really good question as to if NASA already has really high quality satellite imagery that comes in every 15 minutes, why would an endeavor like this to get crowdsourcing images be more useful? And the answer really is it's about data fidelity, meaning that if you have someone on Earth who can take an image of the fire that's happening and you know where they are, that data is intrinsically much more valuable than satellite imagery would be, because you have context and you have just a first-class data analysis of the situation. So really what I was trying to do for this hackathon was to build a web app that would allow people to be able to very easily try and take images through their phone and to kind of answer a few of the questions that were brought up in the prompt, which is, can they leave a note? Can they take the image very quickly? Can this survive in like 3G situations? You know, make sure that if the data transmission is not high, the quality is not high, can they still take it? And so it's just building kind of like this this system that be able to send this the image data, your GPS coordinates, and then have like kind of a running catalog of incidents reports. And you can see it. This is me testing it like really early this morning. But the whole point was that I wanted to push people to be able to be like first-class citizens and submit data in this way, where their data is just as important, if not more so, than the satellite imagery in order to detect wildfires. And I wanted people to, in the community, to kind of come together in not only active, but kind of passively as well, and develop the API system to have people subscribe to want to know, is there going to be an issue where I live? So you can enter your zip code, you can enter like an email for now, but the idea is to have it in any kind of way that you want to be notified, whether it's through Twitter, through WhatsApp, or what have you, in case there is an incident nearby. And yeah, that's pretty much like the front and back of it. I wanted to really push for like subscription so citizens can be aware and citizens can be very active in trying to alert people in their community about a wildfire that might be happening.
If you had a week more to work on this, what would you add? And if you had a little bit more time, like what direction would this take, this particular product?
Well, definitely the machine learning aspect of it was a big barrier for me because I had no experience in that. If getting more help, it'd be basically confirming, I'm not taking a picture of myself, it's a picture of an actual fire. The other part of it, which was in the subscription part, is to make sure that is there an actual major incident happening. If someone took an image of a wildfire in the area that you deem appropriate for you to be notified, that's one thing. But if 3 people took an image, that requires a level of urgency much higher, and we can assess that there is an imminent danger and you should be notified in whatever other way. And really it's about expanding, coming to the people on how they want to be notified, whether it is through Twitter, whether it is through a phone call, through emails, to fulfill reaching to people no matter what.
Do you envision this as the product or a platform to allow other products to have a more effective upload and incident reporting feature?
Yeah, I actually envision both ways. This can be a standalone product, but I have this entire system in place of you deem it an understanding of a subscription of what type of threat model that you want to be protecting yourself against, and how far away do you want to be notified in case it comes in. And the other is an incident model, basically the type of incident, the type of metadata that comes in with it. So in this case, it's images, but I could certainly see audio being a sort of medium of recording data and assessing a threat situation.
Thank you, Hector. Whoop. Next up is stage 1, followed by Lactase, and then Hubble Bubble and Gryffindor. I just want to say thank you all for wearing your t-shirts. This looks great. You guys are all doing a fantastic job. We're about halfway through. You guys are presenting on this laptop? Yeah, we sent you your email.
Whoever's talking, stand between this tape and that tape, okay?
Yeah, okay. Okay, we're gonna switch the order real quick. I gotta download some videos. My bad. So right now what we're gonna do is we're gonna have Lactase come up now, and then stage 1 we're gonna have you come afterwards, and hopefully it'll be ready then. Thank you.
While I'm setting up, if you guys could just do me a favor, think about your upcoming vacation, someplace you want to go, when you want to go, preferably a real one. Thank you. Somewhere terrestrial. No, this one.
Yeah, okay, that's gonna be fine. Yep.
Thank you very much.
Yeah, no worries.
Okay. Hi. Okay. Thank you. Okay. So this is for the Explore Globally challenge, and the project name is Lactase, just the Milky Way. Okay. Who has a vacation planned somewhere interesting? Can I? Oh, I got a judge. Go for it. Okay, Philippines. And what day does it start? Sorry? What day are you going? Oh, December. Which one? 17th. All No, I'll run it in a sec. So tell me if I'm making a typo.
Yeah, 1L.
Thank you. All right, we're going to the Philippines.
1L double P.
All right, and we're going in 10?
17.
17, thank you very much. Okay, so if the internet holds up, which it did, we're going on, okay, on your mark, set, go. So the idea here is that I want to know, are you going to be able to see the Milky Way when you're in the Philippines? Because while we're in New York City, there aren't too many opportunities to see the night sky at all. So when you're traveling the world, it's doubly important to look up and maybe update your Instagram, Snap feed, or whatever. Whatever it takes to engage today's masses with space. I'd like to demonstrate a way of using open space application to plan your in real life interactions with our world and the universe surrounding it. Should be moving around, but I guess it's not. Anywho. So users are currently familiar with the idea of looking down at a map of Earth to plan out their trips. And the big idea here is to connect that experience that you're used to a tool that has all the data available, which is open space, to show you what the universe will look like when you look up. So hopefully people will be inspired to appreciate our place in the universe by adopting usage of the open space platform. The things left to do here, other than make this demo run, is to maybe make the time of day actually change how visible the Milky Way is. Oh, there we go. Now it's running. Well, okay. Give me a second. I'll just show you the 20-second video instead. We're going to Iceland instead, because that's where I'm going in December. Okay, I don't know why it stops running, but anyways, you saw it moving around. In the Philippines in December, you won't see the Milky Way, whereas in Iceland at night you will. Okay, that's it. I don't want to take up too much time. Oh, and a huge thank you to everybody who helped me figure out how OpenSpace works, especially Micah. Thank you, guys.
I have a question. So does your current format of the app or the near future version include an option like I know when I want to travel and where do I need to go to have a full view?
Yeah, so this is what I was trying to demo actually, is in this demo right now, it asks you where you want to go. It's hard-coded to Iceland, but you saw it popped up Philippines earlier when I spelled it correctly, thank you. And the next question is what day? And,
okay,
yeah.
My question is, if I just know the day, but I don't know where I want to go, can your app tell me where I should go to have a full view of the Milky Way?
It gives you a way of exploring that because the Milky Way spins around us over time. So here I'm spinning around the world at the same point in time. So I think I don't know where I am actually. I think that's America sideways from what we're usually used to. And you can see that in the daytime we'll be seeing the Milky Way, whereas if we were in Canada or Greenland, at night we'd be able to see it. Yeah.
All right, stage one, I got your presentation ready to go.
This is how it looks like moving around. If somebody wanted to see it.
All right, we can show it afterwards.
Oh, okay.
Thank you. Okay, here we go. You hold that. Thank you. Good, Jack.
Yeah, I got the phosphate.
Thank you.
Thank you.
All right. Hello, everybody. We are stage 1. My name is Jackie. This is Alonzo, Michelle, and Winston. So when we first found out about Space Apps, we were super excited to finally find a hackathon that melded with our interests, and we dove right in. But as we were brainstorming to see what ideas we can come up with, we realized that we didn't have a single clue about space, even though we all love space so much. Why is that? Sorry. So why is that? So as we started doing research, it was pretty clear that the sites of the lots of resources weren't really made for people who didn't have a background already in space, and like people like us, college students, even though we love space, the jargon, lots of jargon, and the advanced topics easily turn us off. So we made a VR application that teaches you about space exploration by immersing you in the shoes of astronauts, engineers, and scientists. So the way we do that first is by taking you on a journey through Apollo missions, and you start through the assembly of Saturn, the rocket that takes Apollo to the moon. So here, you can learn by, rather than reading text and looking at images, you learn by discovery and picking up the parts and actually seeing how they work. Sorry, the subsequent video doesn't seem to be, okay. Yeah, so then the functionality of each component. So next, you can watch your masterpiece take off in pride, like the astronauts and engineers at NASA. Next, you get to take a unique perspective that you would never get in first person to explore the trajectory and see what the trajectory of the rocket really takes. And that's something I had trouble understanding while trying to research on my own. Through text and images, they don't really convey the 3D sense of what trajectory the rocket takes, and VR is incredible for that. Next up, you get teleported inside Apollo at any point in the trajectory, and you could see and take the spot of the astronauts who went to the moon and feel their anticipation and excitement for reaching that milestone. Lastly, you reach the moon, and you get to see in awe as the physics of the world has changed, and the famous experiment of the hammer and the feather dropping in 0G. I mean, not low gravity without air resistance. All right, so yeah, we're stage 1, and we hope to be the first stage of the rocket that propels your interests to the next level. Thank you.
Did you guys create this like here during the hackathon?
Yes.
And what did you use to put it together?
So we use Unity, and all the 3D models are from NASA sites, all the textures, the moon textures, the Earth textures. It's actually incredible. You guys should go check it out. It's really fun.
And did you guys have the VR equipment here? That was you guys in the video?
Yes. We didn't bring our VR equipment here. It's still very bulky, and we recorded everything at home.
Okay. This weekend?
Yes. We did prepare a little. We spent weeks learning Unity and downloading, getting the art ready, the models. But yeah. Thank you. Thank you so much.
Close that. Okay. All right, that was stage 1. Up next is Hubble Bubble. Yes. Followed by Gryffindor and Satlet. Okay, do I have yours? Hubble Trouble?
Yeah, that's the name of the game.
Okay, cool. I thought I had the wrong one.
So if you want to play the first screen as a video, because you just press space.
Should be able to. We need to download the video.
Is it going to be the same?
Try it.
It might be. Yeah. Okay, so we'll just skip the video. That's fine.
Okay.
So hi guys, I'm Ashley.
And I'm Miles.
And we created Hubble Trouble.
So when we were looking at the Hubble space images, we were like, oh, okay. We were awestruck at how it like looks and all the colors, but we had literally no idea what this was. We looked exactly like this. And so in order to remedy that, we created Hubble Trouble.
So Hubble Trouble is an application that actually uses gamification to teach people about the images that the Hubble telescope takes. So we believe that this is important because there are so many new discoveries every single day that we don't hear about. The Hubble telescope has helped create new technologies in the medical field, when you go to the airport, all different types, even new coding languages, and they're transferred over into so many different other industries. And we feel it's really important that people actually pay attention to the kind of progress that NASA is making. So here's an app that we created that holds the game. So you sign in, and if you go and you see that little rocket up top, actually this is really cool because NASA can actually directly ask questions to the users that they need for a research purpose and actually interact and gain data from the users in return for boosting points so that the game can stay competitive. So if you click into the card here, you'll see what the cards look like. So it's a card game. And on the card, you'll see an image. On top, it says what it is. Then you see a little power unit, which we'll talk a little bit about after, but that's what they use to battle. And here, if you see the navigation and you click that, based on your current location, it'll tell you what stars you can actually see. And if you click into it, it'll show you what the Hubble telescope has taken, what's right above you.
Now let's get into the battle mode. So in the battle mode, you and your opponent both draw a card, and the one that has the higher power level wins. And the game goes on until one player has no longer any more cards. And at the end, you can gain points, and you can level up your little astronaut. For this project, we used the open source database, open space database, and a research paper that let us calculate the apparent magnitude of each of these stars. And yeah, and in order to, it's basically brightness. And in order to validate the apparent magnitude in open space, we calculated the apparent magnitude using the equation by putting the absolute magnitude and the distance calculated in parsecs into the equation.
So when we ran the equation, we actually ran it on separate data so that we can make sure that the equation was correct. And as you can see, the predicted value from that equation was like literally overlapped the expected, which means that the equation was quite correct. So we used that to come up with power units using distance to Earth and magnitude. And last, we think that this is really important because this can be implemented in education systems. It raises more awareness and knowledge spillover on the different things that NASA's doing. It also allows data to be transferred from the users straight to NASA for research purposes. And of course, it's fun. So thank you. Hey.
Were those just mock-ups of the screens, or did you guys actually create the game?
So we created the model for it, but we didn't have time to create the whole thing. So these right here are the mock-up, but the model is created. This model.
Yeah.
So how did you calculate what it would be like based on your location? Or is that still in the mock-up stage as well?
So what you mean like where exactly the stars would be located?
Yeah.
So it's still in the mock-up, yeah. Okay. Thank you.
What are your future plans for this?
Well, right now this model is particularly for stars, so we'd like to make other models so that we can actually talk about different things like nebulas and galaxies and things that go a little bit further beyond, and they can explore that as well. Yeah. Thank you.
All right, next up, sorry, which team was that? That was Hubble Bubble, right? Okay, yeah, we got all these names wrong. Because someone shouted out Gryffindor. Gryffindor's up next, right? Do you want to go later? One second.
Yeah, Gryffindor's next.
Are you guys Gryffindor?
Gryffindor.
Okay, Gryffindor's gonna go next. Right now, we're gonna have Satlet. Next year, I'm going to ask for pronunciations because you guys come up with really creative names, and they make sense once they're explained to me. I apparently just don't get it. Okay, Satlet. Here we go. Safety can. There you are. Present you. Oh. Okay. Sorry. What? What?
It's an emoji. It's not one.
Oh.
How do I proceed?
You just hit the right and left there.
Okay. Hi, y'all. We're Team Satlet. This is a emoji. Oh, here. Okay, who are we? Cameron is a software engineer, Jenny is a designer, Rashid is a creative technologist, I'm Vivian, a data journalist. We're all friends interested in data, and we've all wanted to work together for a while, so this seemed like a really great opportunity. And with that, I'm going to give it to Cameron to introduce our app, Satellites Near You.
Great, so how many people have some sense of how many satellites are above you right now? Or who owns them, or what they're doing? Well, so we are inspired by the question that Nicole asked us during the keynote, which was how do we get people who aren't thinking that much about space to think a little bit more about space? And so we also had two secondary goals for how we would do that technologically. One was we were very inspired by the Dear Data project, which invited people to visualize unusual data sets in creative ways to get people to pay attention to them. And the second piece was, how do we ground the visualization that you're seeing to something about your own life? So with that. So we had to decide what it was in space that we wanted to share with people. And our first thought was, we'll just look at all the NASA APIs and see what sorts of things are changing on a regular basis. So we looked at fireballs, we looked at glaciers, we looked at rocket launches. All these things are great, but they didn't change often enough for us. We originally wanted to do a postcard that showed all these different things in one place, but we ended up focusing on satellites, as our name will show. This was our first pass, so we wanted really early on to get some data, throw it into processing, and see what it would look like, and then iterate on that. A little bit more about our process. So we ended up picking two main data sets about satellites. One was something that we believe uses the Satellite Situation Center's data set to project the locations of the satellites overhead. And the second was a data set from the Union of Concerned Scientists, which provides more data about what the satellites are doing. So that included purpose, the company that owns them, how much they weigh, all sorts of great things. And then we used a variety of different web technologies, including P5, which is used a lot in creative coding, together with D3 for data visualization, and React, which allowed us to develop the pieces independently. And now Jenny is going to talk to us a little bit more about how we decided to represent the data.
So from the initial visualization, we came up with this visual system that classifies like each satellite icons into 4 different colors, which mean like the use of satellite, which is like commercial, government, military use, and like civil use case. And also, this is a really fun idea to have like different numbers of stripes on the wings of satellite. So this means this represents like so each stripe represents a decade. So the one that have no stripe is the most recent one, and 4 stripe it means like it's out there like for 40 years in the universe.
And for our final piece, oh gosh, right. Let's do the live demo and click into it. So for our final product, we made a web app that allows the user to see the satellites that are above them presently. So what we do is take the location of the user, and they're greeted by the visual glossary. And as you scroll down, you see the satellites that are above you, including those in geostationary orbit, in middle Earth orbit, and lower orbit.
Is this going to have, or does it currently have, like a 3D?
It doesn't currently have 3D, but we think that could be a way of iterating on the project, just having that component and adding the orbits and so forth.
Awesome.
What's your vision? Like, I mean, assuming you had more time than 48 hours, what's your vision for the end product for this, and who would use that?
So I think the user would be a curious sky gazer, someone who maybe has an idea of like a few satellites that they know their cell phone talks to them, but would like to know more. I think the end product could be both app or mobile, but just kind of informing you about what's above you right now, basically. Yeah.
Here it says 50 of the 2,221. Those 2,021 are above us right now, or those are the number that are?
So we used an expansive, it's basically a cone that within a certain degree picks up the satellites. We made it as expansive as possible for this particular instance, partly because we were connecting with a data set by the Union of Concerned Scientists, and they have data on particular satellites. And for this app, we also wanted people to be able to see information about the satellites, like who was the contractor that made it and what country put it out there.
All right. So you guys went. Well, I need to check a couple off. Stage 1 went. Anita, stage 1. That was the name, stage 1. Hubble Bubble went. Gryffindor's up. Gryffindor, you guys ready to go? Gryffindor? Okay. Yeah, sure. So after Gryffindor will be A Better Home Planet, followed by Hubble Telescope Tonal Recall, and This Team is on Fire. Using your laptop?
It's just notes. It's just notes.
Do you have a presentation right here? Yeah, I just wanted to say. Some people came up here and like,
I lost my voice. I can't do it. Sorry.
Hey everyone, we are Team Gryffindor, and all right, we're Team Gryffindor. Our project is Home Away from Home. When we got started, wait, okay. When we were deciding on what problem to tackle, the one we decided to go with is the situation with the water. It was a situation that worried us the most. It's, you know, with Syria being in the news, current events, civil war, all sorts of things happening there. We decided, what can we do to help with the refugee crisis? What can we do to help with people that cannot escape Syria? And one thing that's often overlooked is just a bare necessity like water. It is kind of a big deal. There's about 13.1 million Syrians that are currently displaced, and 6.6 million of them are internally displaced refugees, meaning that they remain within their home country of Syria. Again, politics in Syria, attempts to overthrow the government, triggered a civil war in 2011, and Syrian drought in 2006 initially caused this political unrest. Water is being depleted in Syria and other countries in the Middle East more rapidly than almost anywhere else. Here is Syria. The majority is barren desert. Just rock, dust. Not much else in most parts. Dire emergency. In dire emergencies, we need at least 7.5 liters of water a day. That's like 2 Pepsi bottles. A little more. Now 3. We chose to start by using NASA's resources to help internally displaced refugees still within Syria's borders find water. Okay. Everything good? Our web app identifies existing Syrian refugee camps and provides a platform to add newly discovered ones. We also used NASA's gridded population data of the world to map surface water sources in all of Syria. Through our app, NGOs and governments can identify local water sources by clicking on any refugee camp. Our app populates with which nearby settlements have groundwater and lists them in order of proximity. Oh my.
Oh, shit.
Free advertisement. Oh yeah. Shameless plugs all around. That is not ours. Oh. Where did we go? As you can see, disasters can happen anywhere.
It disappeared. Look at that.
It's a power. We apologize for the technical difficulties.
There we are.
All right.
So many presentations.
We got started identifying how things are now, making it accessible through an intuitive tool. This is the first step in providing tangible, on-the-ground solutions to solve the world's most complex problems. With more time, here are some of the features we would have developed. Here are the refugee settlements in Syria that we know about through the UNHCR, but this isn't all of them. Data is incredibly difficult to get on Syria, unlike Turkey, which has an incredible amount of data. So Syria is definitely a place that is in dire need of more data. If you look at the satellite images of Syria, refugee camps aren't difficult to spot, despite the amount of informal content. We also have plenty of examples to show that these settlements are actually pretty easy to spot if you know how to look at them, where to look. Folder. Oh, okay. Transporting water is also an issue. It's not a flat country. There's mountains, there's rocks everywhere.
We ran out of time, but I'm having a hard time connecting how you're solving the access to water, right? So the data looks like you're showing where the refugees are, the displaced people. Where does it actually?
Well, if we go back to the video, the idea is that you would input your coordinates or the coordinates of where some refugee settlements may be. It gives you an idea of the available water in the area, whether it's sufficient to support the people there, whether it can support more people or should support less, give it an idea of who should go where.
Does it also help you identify other water sources if you input like where you are located?
Yes, that is a future goal for this project, to be able to just find your water sources anywhere.
And who's your target audience for using this? Is it
NGOs. All right.
Thank you.
Thank you.
Hello, everybody. All right, got that one done. All right, next up, where's my list? Here we go. Next up is A Better Home Planet, followed by Hubble Telescope Tonal Recall, and then This Team is on Fire. There we go. You guys got going? The sound should be fine.
Put it on there, right?
Mic check. All right. Hello, everyone. I am Jan Sol, and this is.
My name is Anna.
And we are the team A Better Home Planet. We decided to take on the challenge, help others discover Earth, and produce a documentary, a Space Apps documentary. And this is a documentary about space apps. This event today called For the Sake of Humanity. And what we're looking to do with this documentary is to show other people how important space apps is so they can get involved more with the space apps around the world, actually. At the same time, we were producing this video. We were also working on a website, which is still in development. We're hoping to finish it soon, today, where we want to have a blog. We want to connect your projects through the Space Apps link, and we want to have like an open platform where people can share their photos around the world, their videos, and their projects as well. And yeah, so without further ado, let's play this.
Martinez. I'm the Executive Director of Space Apps NYC. We're a nonprofit grassroots organization that has hosted the Space Apps Challenge here in New York for the last 7 years now.
Space Apps is this challenge that is about coding, but it's also, when we talk about space, concepts of a wider view of humanity, our place in space. And it excites people because it's about the future. It's about how we can use this environment that's outside of ourselves, outside of our living condition, to try to draw ourselves together.
I'm Micah. I work for the Open Space Project at the American Museum of Natural History. We came to Space Apps to be a mentor and partner to help teams use open space to complete their hackathon projects. Open Space is an open source data visualization platform that can be used to show cutting-edge science on a variety of mediums.
My name is David Pentecost, and I'm the Director of Technology at the Lower East Side Girls Club. We built the Girls Club with a planetarium and lots of great rooms for people to be creative in, and so it's perfect for us to host the Space Apps Challenge.
My name is David Margolin. What I like the most about the Space Apps Challenge is the space. The Lower East Side Girls Club is probably one of the best places that I've hacked at. They have a planetarium, which is super awesome.
My name is Aisha Ogilvy. I'm just like Georgie. I'm still with the people. Being able to meet so many people from different walks of life, but definitely being a new developer, to meet other developers and developers in the making that are all here, and also the opportunity to learn from people who are very experienced.
Yeah, so the best thing about the challenge was all the people that we got to meet and being able to try to solve this problem on our own, even though we know that a lot of other people are trying to do the same thing, and everybody is trying to attack it in a completely different way.
Hi, my name is Heather Bowden.
I'm Mario Gilchrist.
Gryffindor.
There's some pretty interesting talks going on. It was glad to see, wow, so many people just participating, having participated. It was incredible to see how diverse this community is.
Because we are friends and it's local.
I will stop now. Yes. We are probably
Can you describe in one word
Let me
how
show
you
you
would
the ending
describe
of
this
this.
Space App Challenge?
At spaceapps.nyc and visit spaceapps.nyc for more information.
We had a very emotional, inspirational ending. All right. And yeah, so in the video, in the computer, it was louder, but all right. Any questions?
Are you going to share it out anywhere?
Sorry? Yes, so the video, again, we're uploading it to the website that we are making, and we're posting it on the repository and the Space Apps. Okay?
I'll just say, as a video guy, the first thing about video is audio. And if you want to do this kind of thing, it's a great video, but the audio sucks. You should really improve your mic.
Thank you. Very kind of you.
Thanks, Jolly. Wait, so does this mean, do you want to add some of the presentations?
So some of the things about video and making any form of short, yes, it is the audio. We didn't get a chance to add the audio. Everything is like, when it comes to anything video or photo, it's all about cropping and adding the color and changing and tweaking. So we didn't get an actual chance to add the audio that we recorded on top of that, or even fix it, or even the color, or making sure that it's edited at the right moment with the right transitions. Last night we decided we wanted to join other teams, and they were like, you know what, let's do the...
At 6 p.m. last night, we made this. So
yeah, we were like, let's do this documentary. Nobody's filming. It's an experience. It documents you. It documents us, and this year, especially for all the newbies. So,
Thank you. So, if you actually work with Jolly's been filming this, so he's filmed all the presentations are being filmed. So if you actually want to complete this, you could get B-roll and some of the like proper audio from the film that's actually ongoing. Yeah. No, seriously.
Yeah, if you recorded audio separately, it can be fixed in post.
Yeah.
Okay. Thank you so much. You want to just like read it? All right. They're going to continue working on the documentary, and when they're done, we're going to post it up on the spaceapps.nyc website, so you'll all be able to see the final product. All right. So next up is Hubble Telescope Tonal Recall, followed by This Team is on Fire. Yeah, okay. And SM Safety. Okay. And you got your own thing?
I got
Cool.
HDMI.
You got yours.
You look so sad right now.
Yeah. No.
Sorry. Good. And let's see. Presentation. Hello everyone. My name is Peter, and when I was choosing my challenge, the one with the Hubble telescope, there's one sort of partial quote that said, "Shoulder of giants," and I just, of course, looked up who said it, and it was Sir Isaac Newton 400 years ago, and it's 400 years later, it's we're staying on his shoulders. Hubble wouldn't exist because of his laws of motion. And a couple things about Hubble. I mean, it's a fascinating. He probably didn't foresee this 400 years ago that we would see it as far as he thought we could see. It's $1.5 billion, launched in 1990, 140 gigabytes of data per week. It went 17,000 miles per hour around the Earth. So I took this challenge, and it was to create a game using images from the Hubble telescope as integral components. So I had 3 goals for this challenge: to be accessible. So I wanted to make a game that could be for 5 years old to 95 years old. So a simple mechanic that most people are familiar with. And also I used technology, a web technology called A-Frame that allows for immersive web experiences from the Google Cardboard all the way up to the HTC Vive. It's an opaque technology. I wanted to create something that inspired exploration, to keep furthering creativity and interest in science, and also to celebrate the legacy, the shoulders that we stand on. So I created something called the Tonal Recall game, pun intended. So let's go to the demo. It's right here. So this is web VR, if not familiar. So it's a star chart, and these are the Hubble images. I placed them in the location where they were actually taken. So these point to the point, where Hubble actually can see beyond never before seen. And some stages are locked. I use the same sort of gaming paradigm with stars to level up. So let's go in. And you go through. And yes. So now you're into that image, a high-res image in VR. And these goggles here, you can actually go into VR if you had the goggles. So if I play the game, let's see. So it's sort of like Simon. So that's the days, but if I had the HTC Vive, I can actually use controllers. So I'll guess wrong, and I'm out. So I go back to the menu. Oh yeah, I'm sorry. There's actually factoids under each under each so you can you're learning also a little bit about each photo, and I guess if we could programmatically even swap out data eventually. So yeah, I found a little Hubble on NASA. They have like a free model, so I put that in. And that's the demo. And I'll go back to Earth here. And thank you very much. Questions?
So how did the game work exactly? You had to repeat the tones?
No, it's like a Simon game. So like there's a sequence. So first it starts with 1, then you try. So that each star blinks in a sequence. You try to follow each sequence, and eventually, if you don't follow the sequence, then you lose.
Okay.
It's just unfortunately, there should be a number, a numerical value. So like say you get the high score, and I think also in the main menu you should be able to see the numbers when you get the high score.
What does the final product look like? Is this like web-based, mobile? Is this VR headset?
Oh, yeah, it's web-based, so you can run it in any browser, right? Which is the beauty of it, and one on mobile browsers now too, because now just this year, web VR is available on mobile browsers, and it's cross-platform. And I envision like the Earth and the Sun actually rotating in real time, and you can actually move it forward and backwards in time and see the pictures would move along with it, and also. You can dynamically create more photos coming in. And I would also it was manually, I put those in manually, so I'd probably be more automated way of doing it. That's probably an idea I would like to try.
Yeah, I was going to ask you how you put it all together and what you used.
Yeah, so it's web VR. It's all JavaScript, HTML, CSS, and yeah, the star chart, I use that as a way to find the constellations, and then based on the constellations, I actually manually put in where the pictures were. Thank you.
Thank you. Next up is This Team is on Fire, followed by SM Safety and Meteorite Partners. You guys using your laptop? Yeah. Yeah, sure. Thank you.
Testing. All right, just making sure. I'll plug it in. Perfect. Sorry.
This actually.
Where got the stones?
Yeah, so between this area right here.
Okay.
Look at this line.
Like that.
There. Yeah. Okay.
On that line is good. Stand on that line.
It's not really.
Can you trigger it on and see if it's...
There we go.
Okay, so it's on the other.
No.
Wait, what?
We tried. Where did it go? Hey, Google Home. Google Home, yeah. And then it should be on. No, it should be on this browser. Yeah. No, that's not it. That's not it. I don't know where it went. It's on the other screen. I heard it back.
It's probably weird, so you have to drag it over.
Easy to say, harder to do.
Wasn't it full screen, so I'm full screen it, drag it over.
Oh, that's the images. That's not right. Alright, that's whatever. No, that's not the right presentation. This is not the right presentation? This is the one. Yeah, that's it. Okay. So it's alright. The sea was literally on fire. Okay.
All right, good to go? Okay, greetings everybody. Just a quick intro. Our team name is called This Team is on Fire. We're kind of inspired by Alicia Keys. I don't know if you guys know her. You know that song. Girl is on fire. No? Yeah. All right, so let's get straight to the challenge. The challenge that we chose was called Spot That Fire. And this is a challenge that connected with all of us. And we just felt like we can tackle this challenge. So let's get straight into it. The problem. So we know that especially in the West Coast, wildfires are very common in the US, especially in the southern areas. So we had 3 points and 3 problems that are facing especially in the West Coast, which is right here. So we thought this app called LitSpot. And we asked our question, how can we reduce loss of life and increase awareness of wildfires? So our team came up with this idea called LitSpot. It's an app that's for iOS and Android. And what this app does, it's actually lit. What this app does is actually, number one, it's an app that reports and recognizes wildfires around your area. It's also an app that notifies people in your community when there's a fire is confirmed. And also, it gives instruction on how to evade and also survive a wildfire. So I'll be taking this mic to David to show you a quick demo.
Can you hold it for a second?
Okay.
So let's get out of there. What's the website? Sorry. Cool. All right. Cool. So we have a mirror of our screen. So this is the LitSpot app. As we zoom out, you can see we have data from something called VIRS, which is a sensor that recognizes heat. It's on a satellite circling the Earth. And so the colors of the circles are based on the intensity of the heat, fire radiative power. We get this data from NASA Earth. And when we click on a circle, we can see the data, which is unfortunately not showing up. Oh, there it is. Cool. It's a lot faster on here. And then, so all of these heat spots aren't necessarily wildfires. So what we need is confirmation from the public. So what you would do if you thought you saw a wildfire is you can click on an area, get the information for it, and then click report fire. And we have an algorithm that checks to see if there's even a possibility of a fire being there. And if it is, it'll show the fire on the map. Eventually, it'll show up on that screen as it has on mine. There it is. Cool. Another thing we want to do is we want to demo push notifications. So if you've ever visited our app, we save your last known location. And we want to tell you if someone has reported a fire in that area. Unfortunately, New York City does not have any wildfires, but we created a mock tool that allows us to create a wildfire in New York City. So I'm going to skip past notifications because we have something more interesting, which is our Google Assistant integration, which Shin will demo for us.
So our LitSpot assistant, hold on a second, let me open it up. Talk to LitSpot.
Hi, I'm your fire hazard assistant. You can say more info to get more information.
More info.
Unless otherwise noted, contact city government offices.
I have a question. So you said that you have the user input that, okay, here is a fire, and then you have an algorithm that is going to actually check whether that's a true claim. How does that algorithm work?
Yeah, so it looks at the heat sensor data and it gives it a little bit of padding. So maybe you see the fire and it's not quite in the middle of the wildfire. And so the sensor wouldn't necessarily pick it up. So we give it a little bit of padding around the actual detected areas. But if you click outside of in an area where there definitely couldn't be a fire, it'll give you a message saying this is an unconfirmed fire and we can't confirm this.
So the heat sensor data, something on the ground is really hot, or like the temperature is really hot there?
So it's something on the ground that's really hot. It doesn't have to be wildfires. It could be factories or like a power plant. So that's why we need verification from citizens. And that's why NASA posed this challenge.
Wait. Ayo. Oh, my bad. Sorry. I was on fire. Sorry.
All right, next up is SM Safety, Meteorite Partners, and then Babel Knots. Babel Knots. Are you guys using this meter? Okay. Yeah, just check it. All right.
Yeah. Yeah. Okay. I'll introduce each other. We're gonna introduce. Wait, are you gonna introduce us? Oh no no. Oh yeah. Okay. Hi everyone. So our project is.
When you're presenting, just make sure you stand.
Okay.
Where she's standing.
Awesome. Our project's called SMS Safety, and it is a disaster preparedness SMS chatbot. I'm Valerie.
I'm Peggy. I'm Christina.
And I'm Shu. So with global temperature rising, weather conditions are happening more and more often, and that disaster preparation can save many lives during extreme and sudden weather conditions. So the problem we have on hand is that a lot of people develop app-based application that uses data packets, while actually during these conditions and extreme weather disaster, a lot of data are lost. So the only thing that's left is either cellular towers using SMS technologies. So what we came up with is an SMS disaster bot, which to track pre-disaster and post-disaster states of people affected, and also give them a checklist of what to pack and how to prepare for these disasters. And then,
so to build this, we used Twilio to build like the SMS part, and then we also made a backend in Python and Flask. And like we use Twilio Studio, and this is like one of our chat flows, and this is our other chat flow. Okay, so yeah, this is the screenshots of the conversation you would have with the bot. This is like an actual screenshot. It's not like a mock-up or anything. So this actually worked. And it asks for stuff like, are you planning on evacuating? What's your zip code? How many individuals are in, how many individuals are in your party, whether or not they have mobility issues. It also gives you a suggested, like, this is a template for a checklist. Like if we had enough time, we would have developed it so like people could customize this checklist. And then it also asks people like how many items, which one of these items they have. So then like this data can get sent to NGOs so that then they're more aware of like what resources are lacking in the area and what they need more of. Yeah, and the other thing is it asks if like you know of any other individuals who might be affected by this hurricane, or yeah, by the disaster. The one we used in this was a hurricane. So that this way, the bot is also able to text those other individuals, and they're still able to access this technology and these resources, even if like they don't have data access.
Okay, so, and this is another, this is our post-disaster flow kind of. We had two flows, one that was right before, like around during the time of evacuation, and then post, which is shortly after the disaster occurs, to check in with people again. We asked for the location twice, in pre and post. And we want to end up tracking their displacement, kind of, to see where they end up. We also asked them what resources they need, and if they do need resources or something like that, we direct them to the nearest safe zone. Yeah.
How do you? Okay, so we have a landing page. How do I get to? Oh, there we go. So you would be directed to SMS safety, and when you scroll down, if you scroll down, there's two different dashboards. So there's one for the citizen and one for the NGO. And for the citizen, I'll just say it. So for the citizen, there's going to be a checklist like recommended for, like, so let's say a hurricane, and also there's going to be like where you can customize it, and also we can sign up and add the members who are in your party. For the NGO side, you're going to talk about the safe and unsafe zones and the resources that they're needed to visualize the data that you got from the citizen. Any questions?
So is this live now? Like, did you manage to execute the web-based portion
Yes.
as well?
Yeah. Well, so this is more of like a mock-up. It's a static page. It's not connected to any actual data.
Okay. What is your plan to, like, what are you planning to do with this after Space Apps? Like, is there a plan to develop this further? And a year from now, like, if you had time to work on this, what would it look like?
Okay. So like we mentioned, like we want to build out the dashboard more, so then like NGOs can visualize the data better, and then like also like monitor the resources in the area and like see where everyone is and like track people better.
Last question, why NGOs? Why not the government? And why not like scale this out so governments around the world could like use something like this?
We want to contact the local NGOs because they're the ones that can most rapidly do something about the issue at hand. A lot of times it's hard to get people out to disaster areas. There's a lot going on. Systems are down and stuff like that. So we think that NGOs that are around the area could impact people around there that need the most help the most. Any other questions? Okay, thanks. Thanks, guys.
Thank you. Oops. There we go. All right, next up. Whoops. Oh, yeah, I could do that. Let's see, that was, sorry, which team was that? Which, Meteorite. There we go. All right, next up is Babel Knots, followed by Absolute, and then Space Snaps. Mark those guys off. Babel Knots. Can you hold this?
Yeah.
In the back. Next thing, bye.
Thank you. Got it.
Here we go.
Ready, steady, go. Hey guys. Was I loud? Hey guys, we are the Babel Knots. I'm Aditya, this is Connor, and this is Tom. And we are here to let you travel the universe without even lifting a finger. Let's jump straight into the demo.
Hi, everyone. So when you want to interact with our service, there's a lot of different ways you can do this. One is that you can go to our web application. So you can imagine me as like a young person, 5 years old. I know I look that age. And let's start listening. Go to Mars. Look at the moon. Go to the moon. Speed up. Slow down. Look at Mars.
So that's what our app does. Oops, sorry. Cool. So basically, OpenSpace is this awesome visualization tool. It can show you an accurate representation of the universe, but it's not very easy to use unless you're a developer. So we wanted something that a 5-year-old could use, or even somebody as technologically challenged as my grandfather could use it. So that's why we created this. Basically, it's a human interface for OpenSpace. And how it works.
So in our demo, what we have is a React.js application that the client interacts with. When you state a command, you use the browser speech recognition API, it detects it, and then it sends that to our Node.js API server, which then interprets that command and then turns it into the relevant OpenSpace commands and activates that on the platform. So you can imagine this in kind of a broader scenario. Say you have any command, go to Mars. Any type of microphone device can pick that up, whether it be an assistant, whether it be your laptop. The voice recognition will understand that. It will send that to the Node server, which is controlling your OpenSpace application. It translates that command into OpenSpace directions, and then you'll see the result on your screen.
Cool. So where do we go from here? Our main focus is to increase accessibility as well as functionality. And as far as accessibility goes, we want to make it so there's a two-way dialogue between you and the software, rather than just being a monologue. We want you to be able to get feedback on what you're looking at, information, astrological information and data and things like that. And as far as functionality goes, we want to have it so that there's more of a vocabulary in order to inform the software of what to do. And yeah, that's about it.
We think this would be great for educators, scientists, students, anyone who wants to explore space in like a really intuitive way. And then expanding that vocabulary, expanding the functionality, I think would be great for further space exploration, getting people excited about space, and also I think it'd be very fun and useful here in our planetarium at the Lower East Side Girls Club. So thank you very much. Thank you, Micah, for helping us out with the open space stuff. Thank you, Space Apps. It's been a bunch of fun. And thank you, Lower East Side Girls Club. Wonderful space. Thank you.
And if you want a demo, just come stop by, find us.
So can you connect this to Siri and tell Siri to go to Mars?
We can. That's what we want to do, right? That's exactly what we're going to do.
Or Alexa.
Yeah, what's interesting about this is that you just need speech recognition on the front end, so you can connect this to any type of assistant that will be sent to our node server, which controls the open space application. So this kind of like dual stage process makes it really easy to get those voice commands from tons of different sources.
Cool.
So what is the hyperspatial jump plan for the features you're adding?
Yeah, so what we wanted to do was have this feature of zooming out slowly, drifting away from the Earth, so to speak, and then you could have random hyperspatial jumps, jump from one part of the universe to another.
Imagine having a dialogue with the application, like go to Mars, explore this part. Oh, imagine saying like go to Mars, add this atmosphere, highlight these characteristics, and because those commands will be interpreted by our Node.js and turned into open space commands, you'll be able to see that in real time. So just a more intuitive way of interacting with the software. Voice is the future. Don't you want to talk to computers instead of tap away at them? Oh.
Alexa, take me to Mars. All right. Did I skip Meteorite partners? I did. Okay, Meteorite partners, you guys are up now. Next up is Absolute and then Space Snaps.
Okay. Hi, our project is called Meet Your Meteorite, and we are Meteorite partners. Woo! So our purpose is, we found as a group, we all enjoyed three things: space, impractical jokers, and meteorites. So our motivation for our project was, there was not much support for meteorite enthusiasts. There was only 2 sites that I could really find information about it, and one of them expired in hasn't updated since 2014. Another one was from 1999, so that was interesting. And we wanted to connect more with meteorite enthusiasts, provide more information and all that. And here's a site of our application. Oh shit. Oops. How do I click on it? Sorry. So our site is deployed on Heroku. If you go to meteoritepartners.heroku.com. Here's how it works. You put in your location, and it loads a bit, and there's a go button, and it'll show you it shows your current location, and when you zoom out, it shows all the meteorite landings that were near you. Scrolling down, it shows it by how far it was from you, 32 miles, closest one from Girl Scouts Club. And when you click on the directions, it shows you where it is, and that's it. For our project, we use React, Redux, Google Maps API, and the Meteorites API. And so moving forward, we didn't get as far as we wanted, but we wanted to implement features that allow the user to change the location, not the current location. We wanted to use Three.js to have a 3D model so you can see all around the world. And we want to use for educational purposes for students to use, because like there's different types of meteorites, and we also wanted to put in like areas that you cannot try to find meteorites, like national parks. You're not allowed. Or you want to put years in jail if you want that. And we wanted to do a more detailed Google Maps showing like how big was the meteorite. And thank you for seeing our presentation.
So I think you said in one of the earlier slides that the purpose is to meet meteorite enthusiasts.
Yeah.
But the product is actually meteorite landings.
Yeah, that was like, our plan sort of changed as time went along on how far we can get with the time process, so it sort of changed. Thank you.
It's like Pokemon Go for meteorites. You go around finding them and then you meet people
That'd be pretty
that are also
badass.
looking for meteorites.
Okay. So that was Meteorite Partners. Next up is Absolute, followed by Space Snaps, Team Rocket, and then lastly, Insta CO2. All right, you guys are using your own.
Hello, we are Team Absolute, and our project is Absolute Rover and Quantum Random Data Generator. It's our team. Our challenge was to develop a sensor to be used by humans on Mars. What's the main problems? First is problem with data transfer. Second is a problem with the battery. For example, you know what's happened with Opportunity Mars rover. Second problem is with Monte Carlo simulation problem with random data generation. Problem statement. You know Mars rover has limited bandwidth. It's only 2,000 kilobits per second, and it only has 8 minutes per day. And what is our solution and how it works? Our solution is our mathematician formula, which I developed 2 years ago, and after I developed the formula, I entered in top 25 best mathematicians of Canada. So we can remove all if statements and make calculation really faster. So how it works? Our robot will analyze the data on a Mars board and send only the result to the Earth. For example, it's dangerous or okay for the people. So this screenshot of the data, it can set air quality, green, yellow, red. CO levels, it's CO, CO2, methane, propane. And what is benchmarks? So our solution can significantly be faster than the standard methods. For example, we can analyze DNA, the damage of DNA chain instead of a few minutes instead of 2 weeks. And second solution was using the control relay, which work if we have energy from solar panel. You can see if we haven't energy, the control relay will disconnect the brain of control panel. And benchmark is we can increase the possible life of the robot during polluting dust storms. And the second problem solution is our quantum random simulator, which is based on photon future sensor. And we use our special lens to generate the random data. For example, if we have energy from light, we generate always each time different random data. And the demonstration and question asked. So this is first demonstration of robot. So you can see it really works. And a second demonstration will be of the demo of quantum random generator. You can see this is only read and write for function without any random and mass calculation for formulas. And so we will send O, and you can see that each time the different values. So we can generate each time random values to work with the different simulations. So it's better than standard random because standard random based on computer process temperature and other computer parameters. And people can manipulate it, but people can't manipulate light.
So maybe I missed it, but what exactly did you reduce the time from 2 weeks to 2 minutes?
Yes.
It sounded like you were calculating something, but I didn't understand.
Replace if statements. For example, you know that percent works like instruction pampering method. For example, if you have if statements is one text, then it's logical operation, and then my mathematician appears. So it's two tasks. And if you write if statements in mass form and add it to your primary formula, so it's only one mass operation. So it's one task. And if you have complex calculation task, you can calculate it significantly faster.
Yeah, but what is the calculation?
It's find I can show the demo. Okay. So it's damage DNA, and this is all information which we generate. So the first line is right, and second also we need to analyze. If we vote in pairs not like 1, 2, 2, 2, 1, it's the damage DNA. For example, we can't write 1 and 3. We need to run 1 or 2. So you can see that. So
it's like the field.
You can see damage is 3 and 1. 1 is.
All right, thank you guys. Where's my laptop? It's over here.
Okay. Wait, so how
Pet the robot.
You said you've tested this against dust storms.
All right, next team's up. You guys are Team Absolute? Hold on. They were Absolute. Space Snaps. I'm going to get this. Space Snaps, followed up by Team Rocket and Insta CO2. You guys using your own? Awesome. What? You have it loaded?
We were just scared the video wouldn't work.
I mean, I think I did load it up, but if you guys have a new version or something. So this line where you're standing on, to the left of it, and yeah, that's good. So
just stay here.
Yeah, right here's good. If anybody else needs to talk, just swap out. Keep the mic right to your face.
Okay.
Thank you.
Drag it over there and then full screen.
Yes. And
I think it's broken.
No, it's not. Oh, it is.
Hello, everyone. Our project is Space AR, and our goal was to inspire the astronaut in every single one of us. My name is Nadeem. This is my team, Erica, Akila, Diani, and Asinja. And there's us, a team.
Yeah, so anyway, we were really excited about this project because we wanted to, given the current environment where science and facts are actually being put on the sidelines when important issues like global warming and immigration are coming up, we wanted to find a way where we can really make science the way we think about things and include science in the way we develop solutions to these global challenges. And we think the best way to do this is really communicating NASA imagery and resources in a way that is fun, immersive, and yet engaging both for young people and educators around the world.
And the solution we came up with, the technological solution for that problem, was to create Space AR, which is an augmented reality frame that can be implemented in Facebook and other social media apps using 3D NASA models. And it's very easy to use and a very limited barrier to access for anybody with a social media account. And the reason we decided to use AR because we thought it would engage people in a way that couldn't be accomplished with a simple video, a text blurb, a quiz. It makes you interact with the materials in a very engaging way. So this is our app. So you would launch your favorite social media app. In our case, we limited it to Facebook, but it can be expanded to elsewhere. You can start a video call or a chat, and then you have these planets revolving around your head. Right now, we've only got 3 in there, but we have mechanisms in place to add more planets. Their revolutions are in relative to the actual planet revolutions, having your sun be the head. And we got to use the NASA 3D space models that were available open source on their site, which we didn't understand what else they would be used for. There's like these amazing satellite images and astronauts, like the little astronaut on the bottom giving you more information, and we wanted to incorporate them. The technology we used was Spark AR Studio platform within Facebook, and we injected JavaScript scripts within that platform. We used Blender to edit the 3D models. The NASA 3D models were provided open source on their site, and we implemented it in Facebook.
All right, so what's the future of this project? Our vision is to gamify it. So for kids, they could, or anyone really, could go explore different regions in space and collect different, what do you say, filters. Yeah, so they could collect different filters, and then filters like the solar system or whichever area they're in. They could collect that and show off to their friends or something. That would be something cool. We could also do 3D emojis with the data that we have. We could use open space for our 3D models, and we hope that this will be open source. Yeah.
Join us. That are our contact.
You mentioned in the beginning that I think you called it a frame inside social media. So is the thought that this would just be a plug-in to whatever social media channel someone might be using. This could be almost like filters on top of existing apps, or is this its own app?
Yeah, we wanted to focus on the accessibility and inclusion, or the ease of use. And Facebook, actually, the studio Spark AR already, you export and then you import it into Facebook. And obviously they review, but once they approve it, it's available as a filter. So anybody could just search when they are chatting and be able to add it to a conversation. So that's the level of integration we'd seek with other platforms, whether it's WhatsApp or Instagram, and really allow educators to extend this in as many ways as they can. And the one thing that we, think that all the other resources like OpenSpace could help with is really just dynamically loading materials. So if you think of over time knowing what a kid is interested in, and then like each time you surprise them with a new image or statistic, that's kind of where I would see this going. Yeah.
Okay, that was Space Apps. Cool. Next up is Team Rocket, and then Insta CO2. We will be doing Team Rocket in 2 minutes. Please all remain in your seats.
What about us?
You guys can wander around if you want.
We're running your plan.
Yeah, okay. Bye. Cool. You guys got your own? Okay. Where is Insta CO2? Are you guys in here? Okay, cool. Do you guys need my laptop? Are you guys on your own machine? You're on your own? Cool. If you're on Wi-Fi right now, we only got 2 teams left, and we just want to make sure this is as seamless as possible exit of the program. So if you all can just shut down Wi-Fi for 2 more teams, we really appreciate it. And you're good to go.
That's it.
All right, everybody. So we are Team Rocket. My name is Tom Lorenziano.
My name's Joseph Pecura.
And our project is Rocket Power. So the challenge that we chose is, do you know what the next rocket launch is?
Well, ever since humans first made it to space in the 50s, we've always had a fascination for everything beyond the sky. Nowadays, many rockets are launched for many different reasons. Some are used to put satellites in orbit, others are used for research and putting people in space for the International Space Station and whatnot.
I believe in 1957 we started going to space. That year there was basically 0 space missions, and it kind of kept climbing since then. So how many of you guys know how many rockets were launched this year, or last year, or over the past 50 years? Before this project, I always kind of assumed it was like 5 or 6 a year. Apparently, as of 1967, it was already hitting 50 a year. And then during the Cold War, it started to peak even higher. Back then, it was all mostly military and that kind of thing. And nowadays, we finally reached the age of privatization. So you have private companies going to space. So what we did is called Rocket Power. Rocket Power is an educational platform that allows you to simulate upcoming rocket launches planted basically on a globe, so you can see where rocket launches are happening in the future and in the past. It allows you to visualize basically how much we've advanced over the past 60 or so years, and how much things have changed from who's funding these space missions.
Rocket Power makes it easy for individuals of all ages to learn about the many space launches that occur globally every year. In the future, we plan to add additional information to Rocket Power, such as projecting the actual launch trajectories of each launch, which we really couldn't get the data for because there's no real data source for that right now. Rocket Power has the potential to be used by businesses, government agencies, educational facilities, and individuals for a number of use cases, such as events planning, national security, and demonstrating to the next generation of humanity just how awesome space really is.
All right, so the technology that we used, so we used WebGL for this. Neither of us have ever actually done anything with 3D, let alone OpenGL or WebGL. So that was pretty fun learning for this. Whole thing's served up with just an Express server on Node. And all of our data came from the launch library. Turns out they actually have a lot of data on rocket launches specifically, like that's what they do. So, and then we have a demo. All right, so this is Rocket Power. I know they look like candles. They're supposed to be rockets. We're not really good at modeling either. So each of these rocket candles represents an actual rocket launch upcoming in the future. I believe over the next 20...
I believe the data, we limited it to 20, but only 19 of them had actual data for location, so we filtered out what didn't. There were a few of them with placeholder dates, so you'll see a lot of like November 1st, December 1st, where they just snapped it to the beginning of the month, but there are also quite a few with dates. In the corner, it actually has the next one listed, November, now it says November 1st.
So if you had more time, what would you add to this, if anything?
definitely the rocket trajectories. What we were kind of hoping to do was to be able to visualize where each one of these rockets end up going. So you could see where all of these missions end up leading to, where we have planned missions leading to, and also where we kind of stand compared with the world. You can see basically what our priorities are versus other countries, which is always interesting, but that data is apparently really hard to find. So if you could find it, that'd be cool.
All right, last team up, Insta CO2. Woo! We're almost there, folks.
Hey, mates.
There you go. You need. I think I need the other one. There we go.
Thanks. Oh, do you have the time? Yeah, I can see it. Maybe put it up here so I can see it.
We're gonna start beating. Oh my god, I was just kidding.
That's like the first half of our presentation.
It's an automatic win if you do that.
Good afternoon, everybody. We are Team Insta CO2. So everybody these days is telling us, save the Earth. We get inundated with messages, you know, hands touching globes, recycling logos, talking planets, lots of information. And we get told how to do it in N different ways. You know, there's so many articles out there. And even our governments are telling us, these are the four large Western governments, and they've got different government policies on how you should save the Earth. You know, some like there's obviously some overlap and some points which aren't covered. But what's the truth? So we went back and we did a little bit of analysis and a bit of research, and we found out that of all these suggested tips, they have varying degrees of impact. And what we wanted to look at was the carbon footprint equivalent of each of these steps. So if you look at it, well, we got. If you don't use plastic bags and you use a reusable baggie for one whole year, you'll save 5 kilograms. Thanks. 5 kilograms of 5 kilograms from your carbon footprint. But if you take a bigger picture, oops, oh, yeah, that's right. You'll see that actually living car-free is so many times more impactful than not using your plastic bag. So when people are harping on about your plastic bag, you should be really caring about. Oh, sure. Okay. Yeah, you should be really caring about avoiding one flight. That's 1,500 kilograms off your carbon footprint. And there's a little bit of an elephant in the room. It's actually have one less child. It's a much larger impact on your carbon footprint. So where does that leave us? Here's the big challenge. How do we deliver this effective message to a large range of people? And we don't want to be preaching to the choir. We don't want to be speaking to people who already care about the environment. We want to be speaking to people who probably aren't caring about it and not really thinking about it. And how do we do it in an age of social media, of attention spans shrinking shorter and shorter? Enter Insta CO2. It's an AI-powered carbon footprint analyzer. Your health also leads to your social wealth. So what effectively we've made is we've plugged in our app into Instagram, and with the click of a button, you can go in and analyze your Instagram feed. We plug it into an AI system, and it will go in and look through all your photos, analyze them, and then give you real-time feedback instantly on your carbon footprint. It's, let me get this guy going. Does that work? It's very simple to use. That was really important for us, incredibly low touch. We just wanted 1 or 2 clicks, and you can get instant gratification. You immediately see your carbon footprint and and drop a few hard truths at the end telling you what you could be improving on. So we're looking out for things like flying, driving, eating meat, for example. Okay, we have a demo, but in the interest of time, yeah, it's fully deployed and we pushed it online as well. Oops. And here's our user experience interface. We built out a couple of avatars to associate it with your actual ranking, and also we added a radar graph to give you little tips about exactly where you are most impactful or, well, detrimental to the Earth. This is our stack. We used a lot of different nice software pieces, great logos. In the future, we would like to integrate this further upstream into the Instagram architecture or move it more horizontally, perhaps, into different social media platforms. The hurdles we had was calibrating a carbon footprint model, like how much should we actually add to your carbon footprint? You know, it was a bit of a guesswork. It's also meant to be a bit more whimsical. We're working with AI for the first time. Thank you.
Did you take into account the comment below the image or just the image from Instagram?
We only analyze the images, but for the potential to analyze comments as well and look for specific keywords.
Cool.
Yeah.
Can you give a bit more detail about your AI tool?
It's basically, so we use Clarify, the Clarify Cloud API. It's a pretty general analyzation model. We're just looking for particular keywords, like if somebody has a photo of their dinner and it has beef, and we can recognize that, it's got a certain, like not a single meal portion of a particular kind of meat, then we can predict or map to a general amount of carbon in a loose way.
The current calibration that you have, it's ranging between what rates? So your R value, like your carbon footprint.
So the R squared was related to our recognition value of the images on the AI system, rather than a prediction of your actual carbon footprint, because we haven't gone out and calibrated people's actual carbon footprint versus the result there.
Okay.
It was also a bit of a joke.
Got it. Thanks.
Are there apps like this? For some reason, it seems really familiar to me. Are there apps like this out there right now that's integrated with social media and calculates carbon footprints?
None that we've seen. We're open to the audience. If anybody's seen something similar, we would love to see and compare. Has anyone seen anything similar? No. Oh, what? Yeah. Great, thank you, everyone.
All right, so that was our last team. Congrats, you all made it. Yeah, I think it is the largest number of teams that we've ever had at Space Apps New York, and we got it through, but we've not had longer than these. This is pretty cool. The judges are now going to go off and deliberate about their notes and figure out who the winners are. Before they do, I'm ashamed to say I forgot to introduce them before the actual demo started. So I just want to do that real quick right now. First judge on your left is Tejpal Bhatia. He's head of startup programs New York at Google Cloud, and our intergalactic sponsor, responsible for paying for most of Space Apps NYC. So I'd love to give him a big round of hand right now. And we also have Noemi Dersey and Bruno Goncalves, is that right? Who are both NASA data knots. And Noemi is a past speaker at Space Apps NYC who have spoken many times at our space conferences. And Annalisa Bellares is the CEO and co-founder of Women's Sphere, who has co-organized the Space Apps NYC Hackathon and has worked with us on many other events throughout New York in the year. Thank you. So So we'll let them go off and deliberate, and we actually have to grab a room for them. So we'll hook that up right now. Yeah, actually, yeah, you can go in the planetarium if you want. Any room upstairs, I'm pretty sure it's empty. So the judges are Okay, cool. Do you want to talk now?
I just really want to sort of say a
Yeah, okay. So everyone, we want everyone to stay here because the judges will be right back. We'll finish with the awards and then we'll finish. So if everyone can remain in your seats, we're going to do a few thank yous and acknowledgements of people who have helped out in the hackathon. There we go. So I just want to introduce, most of you have known him from, if everyone can just please quiet down, maybe take a seat. Much appreciated. We can get this moving. If you were here last night, we had a movie in the planetarium at 10:30, and we got to see galactic collisions. This is Carter Emmert, the director of astrovisualization at the Hayden Planetarium at the Museum of Natural History, who directed that movie and is responsible for all the other great things we've seen at the space shows at the Hayden Planetarium. And he's also the head of the Open Space Project, which many of you are now familiar with.
So, thanks, Joe. I just really wanted to thank you, Joe, and I wanted to also give a shout out to Mike Caprio, and and also just this engagement. But the real thank you I wanted to send out was to Micah here. Micah joined us this spring, and he has enabled us. And seeing your engagement here has been fantastic. So I just really wanted to give thanks on that level. And it was very inspiring. I was watching upstairs and still getting a little more work in. But also James is starting to work with us a little bit from Columbia. And so just very proud of all the projects here. Thank you. Okay. Thanks, Joe. Thank you.
Cool. So the other speakers that we wanted to get tonight are actually judges. So we'll have their thanks when they get back. I'm just going to vamp a bit until they get back and keep your attention. One of the things that I did want to bring up is... no, you don't want to hear my jokes right now. One of the things I did want to bring up is just participation in space apps. I've gotten I think everyone can agree here that everyone's had a great time here at Space Apps New York. We've hosted this event. This is the 7th year we've hosted this event. We do it every year. We look for new organizing partners like the Lower East Side Girls Club or SAP or any of the other venues we've had in the past. This is an event that we all love to host every year. We find motivation and inspiration in organizing hackathons where we can get 130 people, which is more than 60%, I think, larger than last year's hackathon, from all walks of life, diverse backgrounds and skill sets to come and solve challenges in space exploration. And if that's something that interests you, not only do we have more events coming up in the year in tech meetups or space conferences or talks and space panels and whatnot, which, by the way, you can all read about if you subscribe to our newsletter, go to spaceapps.nyc and subscribe to the newsletter. But also, if you're interested in participating as a volunteer, we are all volunteers. We all have day jobs. I'm a software engineer by trade, like a lot of people here, building web apps and whatnot, and this is something that I care deeply about, and I spend my nights and weekends planning and organizing with other volunteers. If that's something, even to a small extent, where you want to chip in a couple hours a week or a month or something like that, if you know someone who works at a WeWork and we can get a spot, or know someone who wants to do something, then we should definitely chat, because we're always looking for outreach from the community to help us, because we are members of the community, and together we can make hackathons and events like these a success. So if anybody's interested, please reach out to us. We would love to talk to you about organizing future events in the city. And on top of that, let's see if we can get this loaded. We did recently, so Space Apps NYC, as I mentioned, has been around since 2012, the first Space Apps Challenge, in fact, when there was only 25 locations. And we've grown dramatically since then. We recently, in fact, this past summer, incorporated as a nonprofit organization. And the reason for that is so that we can better manage our funds for large-scale hackathons like these. There are thousands of dollars that go into the production of large events like these, and it's easier for us to gain sponsorships if we were an actual nonprofit organization, not just a few random people walking around with asking for money. So on that note, we have the generous donation of sponsors like Google Cloud, but if you are so inclined, we implore you to visit patreon.com/spaceappsnyc. For those of you who don't know, Patreon is a online platform for content creators. There's a lot of musicians and podcasters and artists and writers on here who use Patreon as a source of monthly income to offset their production costs so that they don't have to feel responsible or worried about how their creative outlet impacts them financially. And so if you were to donate $1 a month or $5 a month, we would of course ship you swag that everyone here loves, the stickers and the t-shirts and whatnot. But it would go such a long way to help us secure food and t-shirts and banners and work with venues for catering and all these things for events for everybody here. So again, we encourage everyone to go to patreon.com and pledge $1, $2, $5 a month. They charge you at the beginning of the month, and it's a recurring donation. It really helps us planning for throughout the year. And also, Dave, did you want to say a few things? So I'm going to hand it off to Dave Pentecost, who is the head of technology here at the Lower East Side Girls Club.
You've seen me here.
You've seen me here.
Hello. So, no, give your money to the Girls Club. I don't know. Give your money to both organizations. So anyway, it was really great. It was really fun having everybody here. We were a little bit concerned about so many people overnight, but it was absolutely fun, and it was really weird to see people sleeping in the planetarium this morning. Somebody said, well, how did it go? And I said, well, it looks like Woodstock without the sex, drugs, and rock and roll. So it was terrific. I hope we can do it again next year. And you can look for us, girlsclub.org. We snagged the domain early on, so we're girlsclub.org. And keep up with us. You can find the Girls Club on Facebook, Instagram, Twitter, the whole bit. So stay in touch. So thanks a lot.
We're super grateful for the Girls Club this year. We change venues every year, not because we don't like any particular partner, but just we like staying independent. There are a lot of locations around the world where one accelerator or one university just does it every year, and we like the idea of this being a grassroots community where no one organization really owns Space Apps NYC. I did just mention we are a nonprofit, so technically an organization does run Space Apps NYC now, but this is a community organization, and we loved finding the Girls Club this year because Dave actually registered as a New York location, and then when we realized we both did, we said, hey, let's team up and do this. And I was completely surprised when I came here and realized just the extent of the venue. I know most of you have been wandering around the second and third floors and seeing all the maker labs and the computer labs and the design studios and the sound studios with a cutout of an airplane that turned into a podcast studio room. I don't know if you guys have seen that. And the planetarium, obviously, I don't know any other organization outside the Hayden that actually has a planetarium. I was kind of jealous that I didn't go to college here because it was much better than my schooling. But yeah, it was such a great matchup for us because they have such a great menu and provided food all weekend, which we are much appreciative of. Allowing us, the staff out front, to come and go and everything. So if you could all just give a thank you to everyone who's helped out at the Girls Club, Dave and Lynn, and all the staff that have helped out this weekend, it'd be much appreciated. Right, so I also wanted to just let everybody know that we will be sending out a survey sometime today or tomorrow. Everyone go home, get some rest, go to work or school on time and get through Monday, and then open up our survey and just take a quick survey about your experience here at the Space Apps Hackathon. We really rely on your input to make next year better. I know that the past few years we've been kind of hit and miss with t-shirt sizes, for instance, and so I have been recording everyone's preferred t-shirt sizes so that hopefully we can be more accurate in next year. Things like that really help us make this event better for everybody. So fill out that survey and see what else. We do have more events coming up. So as I mentioned, spaceapps.nyc, there is a sign-up form for a newsletter at the bottom. There are two options. There is to hear about only the Space Apps, news about the Space Apps Challenge, which is just basically information about this specific event, so coming up in 2019. But then there's also another option for all Space Apps NYC news. And what that means is we have a monthly newsletter that goes out at the beginning of every month, and it includes any events that we think are interesting to people in our community, which means tech events, space events. We posted hackathons there. We posted space hackathons there. We are looking to co-organize the Acton Space Hackathon in the spring, which is much like Space Apps, but it's run by the ESA, the European Space Agency, not NASA. So definitely keep a lookout for that. It's a little bit geared towards startups and entrepreneurship and less about just democratizing space and citizen science and whatnot. But if you are interested in something like that, that's definitely a newsletter you'd want to get on. We also host with Women's Sphere. This is going to be interesting. We have a Women's Sphere is doing a Women's Sphere festival this month after Space Apps, and we're gonna throw a party in November. It's going to be a Belter-themed party, and I don't know if anybody here has read or seen the show The Expanse. I've mentioned it briefly before. It's a sci-fi show, and we're going to have a big cocktail party at a bar themed to a sci-fi show. If it's something that you may be interested in, join the mailing list, come reach out to us. We'd love to get more people involved. Yeah, tech events, meetups. Is there anything, I'm running out of things to say. Is there any, how about we do this, any Q&A? Is there any questions you have for me about Space Apps, organizing a hackathon, React, I don't know, something? Sorry, say it again? So the question is, do I intend to be the sort of lead organizer for Space Apps NYC next year? And yes, I do. There has been little turnover for organizers for Space Apps NYC. The first, one of the organizers in 2012, the first location was Mike Caprio. He actually was a participant this year, which I've been looking forward to that, seeing him as a participant for the hackathon he's been organizing for so many years. He was the lead organizer up until 2015, and then 2016 I took over, and now I'm planning on doing it for the foreseeable future. Now, having said that, we do rely on a team of other organizers. This is not just an effort that I partake in. So you've all met Anita and Dominique. Anita was the one who's been yelling at everybody through my Slack name. So if like anyone's mad at me because of something I said on Slack, maybe not. Anita's day job is to spam people and try to get deliverables from them and remind them to deliver on things. So it really worked out getting everyone to GitHub this weekend. So yes, I do plan on being here for next year. With that said, we're also looking to do other hackathons, as I mentioned, other events. So just add that to your calendar. The next time whenever we hear about the date for Space Apps 2019, we will let everybody know. Jolly, do you want to say something?
Pull up ipnsig.org.
IPNSig?
Sig.org. Okay. Hi. I'm with the Internet Society, and we do live streaming for things like this. That's what I do, and I just wanted to mention that we have a lot of chapters. We have 110 chapters around the world. But we also have this one, which is the Interplanetary Networking Special Interest Group, which works specifically on delay-tolerant networking, so that, and I don't know if you've heard of Vint Cerf. He's one of the co-inventors of the internet. So he's like, if you join this group, you'll become a friend of Vint Cerf because he kind of runs the group, and you know, they're still working on it, you know, on having things so that if you want to like hook up, you know, your satellite or things further away to the internet, this is the place to go, ipnsig.org.
Yeah, Jolie live streams like all of the tech events I've ever been to in New York. I don't understand how you hear about all of them or arrive at them, but I go to a random pitch fest at Silicon Harlem and Jolie's there, and I mentioned somebody, oh, we're getting a live stream, and I mentioned his name. Oh yeah, we know Jolie.
And so, you know, I am paid by the Internet Society, and the Internet Society is funded because we own the .org domain, so every time you buy a .org, we get the money, and it pays for me to be here.
Wow. Right, so Jolie's been here since 2012, live streaming all our events, and we love having him here. Definitely, I know you've all been here, or most of you, I would say, have been here during the hackathon, so you may or may not have seen the live stream. The live stream is posted to our YouTube channel. Go to youtube.com/spaceapps NYC for all past demos, past years, boot camps, all that stuff. This year we've had a bunch of boot camps, they're all posted there. And all of the live streams too. The live stream for this event, we've had several cameras between 4 different rooms on 2 different floors, and then in 4 quadrants, and then in the middle projected what was on the ceiling of the dome. And it was just a really cool live stream that I've never seen anything like that, where you get to see a hackathon spanning multiple floors, 80 to 100 people, plus this visualization of Earth on the dome. And we've gotten a lot of traction of that on social media from other locations.
The funniest live stream moment was actually the very first Space Apps NYC, and I set it up and I left the stream running overnight, and these guys that were like these Puerto Rican cleanup crew came in and they started partying. I was riding home on the bus, I lifted it up and like I got this music blasting, they were dancing in the place, you know, everybody had gone home. It was so funny.
Next year, if you guys are interested, maybe we'll do a karaoke event at 2 a.m. Overnight on the hackathon. Yeah, oh, wow, okay, we got a lot of reaction from that. The movie event was, I forget how it was started. Dave and I were just chatting. I think I made a comment about how I love seeing the Dark Universe show at the Hayden Planetarium, which, shameless plug, if you've not gone to see a space show at the Hayden Planetarium, you have no idea what you're missing. I've seen it maybe 15 times or so, but I also get free tickets because I go to hackathons and stuff. Highly recommend going and seeing Dark Universe. It's narrated by Neil deGrasse Tyson. It's about dark matter in space, and it's much bigger. It seats 400 people. This planetarium seats about 65. Go check it out. I was talking with Dave about it, about how he mentioned he has the entire backlog of all the space shows that the Hayden Planetarium does here, because Carter Emmer, who does all the space shows, is also on the board of the Girls Club, and he helped set up the planetarium. So they got all the really cool shows. And so I was asking him if we could, hey, can we watch like the Journey to the Stars, I believe, which was narrated by Whoopi Goldberg, and they ended that in 2007. I only saw it once, and I would love to see it again. And he's like, yeah, we should maybe have a movie. Like, why don't we just show a movie tonight? I'm like, that would be a great idea. We'd love to break up the monotony of sitting at your computer for like 8 to 10 to 12 hours at a time and get you up and moving around and like checking out a movie or interacting with Carter, which was a great experience. So we're always looking for other things to do, activities at these hackathons. There was one dance party that happened at a museum hackathon, which was a lot of fun. Question? Oh, the question is, will there ever be a Space Apps podcast? And that is funny that you mentioned that, because we've been talking about one for a while. And Mike Caprio, we just recorded the first episode for a podcast called New Space City, which is our hashtag that we use for this event. And what it is the first episode is an intro to Space Apps and our backstory, and we talk about how we both got involved in Space Apps, how Space Apps grew over the years. But what we're planning on doing with this podcast is highlighting the space community in New York. Because because not many people, I mean, you guys know more than most people. You guys are like in the top 1% of knowledgeable space enthusiasts here in New York. How there is a vibrant space community in New York. There is the Goddard Institute for Space Studies, which is a NASA space agency here in New York at Columbia University. They have a bunch of Earth scientists there studying climate change, and we get a bunch of them to speak at these events. There's Honeybee Robotics, which is a robotics, it's a private institution located in the Brooklyn Naval Yard that builds robots that drills into asteroids and mines them for minerals. They've been sending these robots and orbiters into space for about 20 years from the Brooklyn Naval Yard, going to planets and asteroids and collecting minerals. And it's really cool seeing the kind of technology that they're working with. There's Final Frontier Design, which is based in Red Hook in Brooklyn, and they are a manufacturer of spacesuits. Like, no one knew that anyone in New York was creating spacesuits. In fact, Final Frontier Design got a contract with NASA through the Space Apps Challenge because we had someone from the Final Frontier Design come to Space Apps as a speaker, and they interacted. It was one of our boot camps, which is why we highly encourage everyone to come to boot camps to interact with space experts and scientists and learn more about the challenges and see if you can get inspired by something they know. This person from Final Frontier Design gave a talk about designing and manufacturing spacesuits, got a hacker interested in it. That hacker then, their team created this glove which had robotics built into it. It was half the weight of the standard glove that astronauts wear on EVAs, and it was much more flexible, but it also had technology in it that made it smarter and able to use tools better. And it was just a proof of concept, but that landed Final Frontier Design. They used that concept, landed them a contract with NASA to then go and produce it. When I was a hacker here in 2015, actually with Anita on different teams, but we were working together the entire weekend. My project, drinking Club Mate. We're looking to get Club Mate next year. If any of you have never had it, it's like coffee without the crash at the end. Yeah, you're up for all weekend and you don't really notice it. I'm pretty sure it's legal. It doesn't feel like it should be legal. But if you go to the Museum of Natural History has hackathons. I may or may not have mentioned that before. They provide them every year, and I feel like I'm most productive at these events. But when I was a hacker in 2015 at Microsoft, I built this project where it was a WebGL solar system, and you got to like zoom into the different planets and see their revolution and their rotation around the revolution around the sun, rotation and everything. And the purpose of it was to map asteroid paths, but we didn't actually get that far because, like many people here, everyone here asked me, "Oh, well, I only got half of my project done. I don't know if I want to demo." Very rarely does somebody have a project that's finished and they go and demo it. I don't think I've ever done that. I've been to many hackathons. I'm like, oh, we got this far and then everything stopped working. And instead of like curling up into a ball and crying, we just got something like looking okay, and that's what we're demoing. What we ended up with was just a 3D solar system, which looked nice. But then there happened to be a JPL engineer in the audience who came up and gave me his business card and said, hey, this is really cool. We would love to like use this in internal tools at JPL. That's the kind of interaction that you only get at Space Apps and space events here in New York. We co-organize the Space Hackathon at the museum. We're co-organizing the Act in Space Hackathon in the spring. We organize this one. We have all of our fingers in all the space pies here, and we know so many people in the space industry, which is why we're having this podcast to highlight there's a wide variety of space entrepreneurship that's ready. There's a huge market for people to create rovers that more efficiently mine minerals on the moon, or if you can figure out a way to, without the help of solar, without light from the sun to power your rover, if in the dark you can get something from point A to point B at the rim of a crater on the moon. We got infrastructure all the way back to send stuff back home, and you can be awarded millions of dollars if you create a business doing that. Like, there's a lot of really crazy stuff that is not science fiction. There are people that actually prospecting asteroids. There's a whole industry. There's conferences in New York about asteroid prospecting, figuring out how to identify different asteroids that we want to send robots to and break up and use for water, for rocket fuel, because guess what? We're going to Mars in a few years and we're going to need gas stations. Like, this is real and it's is happening fast, and events like these are a really cool way where you can learn more about what's going on in this community. Yes, I hope I answered your question. Bit long-winded. Anybody else have any other questions for myself or for Anita or Dominique or Jolie? Anybody? Question in the back?
Yeah, so you've been running for 7 years, and you say people can contribute to the way. Just say any history of people that have student donations or do you monitor that?
The question is, has anybody pursued projects past the hackathon? There are teams here. I believe Unicode Unicorns is. It was the origami one, yeah. So this is actually a favorite of mine. We've worked with Space Apps Brooklyn in the past because we're Space Apps NYC, they're Space Apps Brooklyn. We're very close together. We've worked with them to promote each other's events and send people to each other's events when we're off capacity. So we're in very close contact. One of my favorite hacks from Space Apps Brooklyn was that one, which is actually, do you want to come up here and talk about it a little bit? Because I could probably give a synopsis, but I also will probably butcher it. So. Thank you. Want to introduce yourself and then talk about it?
Hey guys, I'm Caitlin. So I did this in 2016, and my team built a mesh network of self-propelling origami robots for the surface of Mars. And on our team, we had an origami artist who actually studies math and shapes and does this for a living. And he helped us to create this football-shaped, I don't know what you would call it, but it would flow in the wind. And so we would release them into the atmosphere, and they would just roll around aimlessly, collecting data, mapping the terrain, pretty much anything you can think of that a little robot would do. It would have like a Bluetooth in it, so if it got stuck and it would stop moving, we would know. I think those were the main things we got done. We continued to participate the full year after, and we actually got invited to Houston to test our prototype in the Mars facility that they have there, but we couldn't afford it, so we ended up not going, but the opportunity to go was still present. So, Space Apps has done a lot for me, and I've made a lot of friends, and yeah, so if you guys want to work on your project, continue your social media presence, get your name out there and get people knowing about your projects, because that's what we did, and we got a lot of support. So if you're interested in continuing on, that would be my suggestion.
I love that project. It solves so many problems of weight in space. It costs $10,000 to launch 1 pound of matter off the Earth into space. And so when you build something like the Curiosity rover, which is the size and weight of an SUV with all the delicacies and fragility of a science lab. And by the way, if you've never seen the 7 Minutes of Terror video of the Curiosity landing, it's a great video showing the human ingenuity of NASA and JPL. It costs so much to put rovers on these planets so that they could observe the soil and analyze everything, to the point where if you just dropped origami, something that's very light like paper, and used the planetary winds to push it around, it's so much more efficient. And those are the kind of creative ideas that NASA is looking for by having space apps challenges like this. Let's democratize space, have everybody in the community come together and put their heads together and think, is there something outside the box that we aren't currently doing that can maybe solve this problem in a way that we haven't thought of? There are other projects. There are projects from other locations that have continued on to other hackathons. There was one project from 2015 that did a VR game from the space station, and they've proceeded to other hackathons and won again. If you go to spaceappschallenge.org, I think /blog, there's a blog there, and they do keep in touch with past winners and projects that have gone on and either become businesses or just continued on as hackathon projects, and you can learn more information there. But it is something that we are looking to track in future years, and also help you if you would like to continue on with the project. We're here to help you. We know accelerators and people in the industry who would love to work with you to build out your project. If you'd like to turn into a company, we also know some people that can help you with that. Do the judges have an answer? So I got your email. There we go. Do you guys want to announce it? So do you want to announce the winners? Okay, cool. All right, I'm gonna need some help. Dominique, there's in there. There's all the certificates. If you could just pull out, we'll do one category at a time. Maybe. Oh, we'll see. How it is. There's
There's a lot
there's
of them.
25 per category because
Right.
that's how Staples does
Okay.
things. All right, so it's $18 for 25. It's not worth it. Okay, so we have 1, 2, 3, 4.
There was no best use of science.
Yeah, there was.
There was none in our.
All right, so there are 2 more challenge award categories that the judges were not aware of. So they're going to use their special algorithms of data here to determine who those are going to be. So I'm just going to keep talking. What?
Totally non-subjective.
Non-subjective, very impartial data sets. What was that about? No, we don't. No, I didn't. We didn't. There's no global one. I cut it. Instead of people's. All right, sorry about that. They were. We gave them. This is our fault. We gave them last year's judging criteria when there were 2 new categories added this year. So they're working on that right now. Yeah, sure. The categories. So the award categories. I'm pretty sure I added this on Slack, but I'll just go over it again. The 6 the 6 award categories are best use of data, best use of hardware, best mission concept, galactic impact, most inspirational, and best use of science. And then regardless of the winners for those 6, we then choose, the judges then choose 2 teams to then be nominated for global judging. When you're nominated for global judging, what that means is you then go and create a 30-second video of your project. That's where when you all did the project pages, there was a YouTube link, which confused many of us because there was validation on it saying it was required, but it's not. Anyways, I digress. That video is required for global judging. NASA will then look through 2 global nominees per location, and there are like 200 something locations around the world. So it takes them a few weeks to look through all these different teams, and they will then choose finalists and then global winners. And the winners at the global level will receive a trip to the Kennedy Space Center for a behind-the-scenes tour for a rocket launch, which is really cool. So that's what we're working on. Question? We are not doing a People's Choice this year. That was one of the categories that was left off from last year. We generally follow the global award categories, and they iterate every year. So it's also easier for us because managing a people's choice vote is just one more thing that we got to do. But this is something that we would love to hear on the survey. So we're going to send out a survey of like things that we could improve, things that you would like to see in next year, that kind of thing. If a people's choice is something that you would like, we would definitely consider it for next year. Any other questions while we're... Sorry, what's that? Oh yeah, so I just mentioned something about WeWork locations. We look to do tech panel discussions, TED-style talks, various tech and space events throughout the year. And one of the ways to do that is by hosting it at any kind of venue in the city. One of the most common ones is WeWork. So for instance, Anita has a membership at a WeWork. We were able to do our first episode of the podcast at a WeWork. It's just a very simple way. If you work at an organization, like a tech organization that has a meetup space, and you host meetups, we would love to host a meetup there. We're working with the Open Source NYC meetup community. We're working with the New York Tech Council. We're working with a variety of organizations to host events throughout the year. You got it. All right, I know you're all antsy. We'll get a couple more in here. Any what? Okay, yeah, that's a good question. Does anybody want to come up here and just announce any job openings or anything like that? No? Why don't we just do like an open Slack? Yeah, let's do that. So we're good. Okay, we'll create a Slack channel and you all can network in that. So we got some results in the email. Okay. Can someone help me? Oh, awesome, we got here. So. Loading up the email. There we go. Okay, let's go bottom up. Okay, so first category. What? Yeah, you can move out of the way if you want. I realize I've probably been messing up Jolie's live stream here. First category is most inspirational. This one is a two-way tie. This year's 2018 most inspirational hack is FireCloud and Babel. So yeah, if you guys want to come up, we got some certificates. We'll take a photo. Take a photo over here. Actually, that'd be a good one. If you want to, let's do FireCloud. Let's do FireCloud over here first. If you guys want to take a photo, quick photo. You want the judges in the picture? I mean, everyone's sitting,
Okay.
so...
You can just have them stand there.
That could be your project.
What?
7.
Yeah.
We're waiting for a picture. We're like, yeah.
All right. Let's do this quick. Okay, let's move on. Let's do just one or two photos. Okay, next team. Let's go in there. All right, let's keep this moving. So, next category. Yeah, we're opening up to photos after the event. There's the step and repeat banner. We'll have a lot of great opportunities for photos. The next category, best use of science. This year's 2018 Space Apps Challenge winner is This Team is on Fire. That's those, yeah. Yeah, in front of the banner. There you go. We'll figure this out. Thank you. Photo, photo, photo. Cool. Okay. Thank you all. The next category is best use of data. And the 2018 Space Apps Challenge winner for best use of data is Arctic Reality. All right, it's just you, right? Congratulations. All right. All right. Galactic Impact. The 2018 Space Apps Challenge winner for Galactic Impact is Demeter. There we go. Thank you. All right. Best Mission Concept. This year's 2018 Space Apps Challenge winner for Best Mission Concept is Stage 1. I know you're all tired. You can funnel that exhaustion into some enthusiasm for the last 5 minutes of this event. Thank you all for wearing the t-shirts again. It's so great to have everybody in t-shirts and just to support the hackathon. You want to do what? We're going to order a lot more t-shirts next year, I promise. And in sizes that fit everybody. Yeah, okay. I'm collecting data. We're doing this the scientific way. Okay. Okay, best use of hardware. This year's 2018 Space Apps Challenge winner for best use of hardware is Absolute. There we go. All right, and the last category, this is the one everyone's been waiting for. Best of Show. These are the global nominees that will then create a 30-second video and advance into the next level of judging. The two Best of Show winners for this year's 2018 Space Apps Challenge are Insta CO2 and SMS Safety. Let's get Insta CO2 up here first, and then we'll do SMS Safety afterwards. Yeah, we're doing photos of one team at a time. Or that. Okay.
Okay, guys. Hey guys, congratulations. Can you smiley faces here? Thank you. Oh, me first, always. Thank you.
One more. Hey, Tesh, do you want to say a few words? Oh, yeah, sure. Right. That's cool. Hey, Lisa, do you also want to say a few words? Someone's phone is talking.
Okay, one last. And then one last.
All right, thank you, everybody. I just want to bring up a couple people to say their thanks for their participation in organizing this year's event. First, I would like to bring up Tejpal Bhatia. He's the intergalactic sponsor for this year's Space Apps Challenge from Google Cloud.
Hey guys, great job by all you. Extremely exciting stuff. As the judges, we were impressed with many of your ideas. Really cool stuff that you came up with. Like Joe said before, my name is Tej. I'm from Google. I support the early stage startup community in New York. I saw several teams doing some really cool stuff with some Google Cloud products. Just want you to know that as participants in the hackathon, everyone gets $300 in credits on Google Cloud. So if you want to further develop or tinker on the platform, you have access through this event. And for the startup teams, these are teams that were startups before, or if you want to actually take this project and try to build a company out of it, you get $3,000 in credits. So the links are on the site, and you got the email. You have 2 months to redeem them. If I can be helpful in any way, Joe knows how to reach me, and I'm happy to talk to any of you. Thanks.
Thank you, Tej. Next, I want to bring up Annalisa Ballaras, the CEO and co-founder of Women's Sphere.
Thank you so much. Thank you, everyone, for being a part of this very exciting event and this very special community. So we hope that you stay with us. This isn't just about Space Apps happening annually. We will have parties and we will have many other events and workshops throughout the year. Women's Sphere is proud and honored and excited to be a part of this community. And in fact, we are throwing some additional parties because the Women's Sphere Festival is ongoing right now until November 17. And as part of that, I'm not sure if you met Hannah Madeline Payne. She's run a couple of workshops for Space Apps. She's a cocktail inventor. And we're planning to, as part of the Women's Sphere Festival, take over a couple of bars and change it into the Expanse. So some of you have attended. How many of you have attended the Expanse party that Space Apps threw earlier? So we will be doing another version of that, and we'll convert. Like, how many of you actually watched the Expanse? So this is really cool. So we're actually gonna convert a bar into a Belter bar, serving different cocktails. So there'll be many opportunities for us to come together. Thank you for all the inspiration, thought, the hard work that you've put into this. And we hope that you've made a lot of friendships, and we look forward to seeing you at future events. Thank you.
Thank you. No? Okay. I just want to wrap up by giving my thanks to a few people. First, I want to thank Dave and Lynn from the Girls Club for hosting us this weekend. And for providing us with all the amazing food and the venue and the planetarium and everything. And I also want to give a shout out to Dave. Happy birthday, Dave. Today's his birthday. I couldn't resist that. On that note, I do want to thank all of the Girls Club staff who were with us all weekend, staying up with us all night, putting out snacks and coffee and making sure just we had the best accommodations. I want to give them a round of applause also. Thank you to Google Cloud for this year's intergalactic sponsor and Data Bootcamp. I would love to thank Noemi and Bruno for graciously volunteering to be judges, and we hope we have you back at future Space Apps events as mentors as NASA Datanauts. If you'd like to learn more about NASA Datanauts, please talk to them and Annalisa after the event. Thank you, Annalisa and Hannah, from Women's Sphere for co-organizing this hackathon and all the data boot camps and all the future events we're going to do. Thank you, Jolie and the Internet Society, for the incredible live stream that we talked about earlier from inside the planetarium. I want to thank Micah and the Open Space team for being here all weekend and helping us work out some really amazing projects. I want to thank all the current Space Apps patrons from Patreon.com who have already graciously donated monthly to Space Apps NYC. And again, I encourage everyone else to visit patreon.com/SpaceAppsNYC to learn more about it. I do want to thank the other Space Apps NYC organizers, Anita and Dominique, for the tireless effort they put in this weekend, corralling everybody, getting projects in on time, and Anita is now hiding behind the podium. Please give them a big thank you on your way out after the event. And lastly, I want to thank all of you for attending this hackathon. This is one of the largest hackathons we've put on, at least since I've been organizing this. I know that demos went long, but that just means we got a lot of people here, a lot of teams working on a lot of different projects, which is just so great for us who are organizing this event. And I want to thank all of you for being here, staying up with us all night, and just making this just an incredible and unforgettable weekend of overnight hacking here at the Lower East Side Girls Club. And together we made this event a success. So thank you all for coming. With that, the hackathon's over, and stay tuned for emails for next year's event.
And could you ask people to leave quickly and quietly?
Yes, if we can, just leave quickly and quietly through the front doors, because there are